Hello and welcome to the second Introduction to Photon workshop. I'm going to be here and my name is Nelson and Gavin will be here.
Hello, Phote. Hello.
Hello, Gavin. Okay, so today we're going to be talking about Photon. What's Photon? Photon is a program. It's a server program, I guess you could say. It's a server runtime, I guess you could say. Basically, what Photon is it's an application that you write applications for and run your applications within the context of Photon. And Photon handles a variety of things for you. It's used for networking. So Photon will handle a lot of the low-level annoyances of actually doing network code and allow you to plug in your code into an existing framework. It's very stable, mature, and very quick. So we're definitely going to be having a lot of fun seeing what Photon can do. We're going to be putting together an application that's going to be using a basic wrapper, or we're going to be putting together an application that actually has a bit of a framework for it. Because I didn't want this workshop to be, oh, here's Photon, if you want things to connect, here's how you connect, and then just leave. So we're actually going to be putting together an interestingly architected application, talking about some concerns like multi-threading and how to deal with client and server interaction.
Well, go on. Don't be coy. We're basically putting together a little chat server, yeah?
Yeah, we're going to be putting together basically the framework, I guess you could say, for a MUD-type program. It's going to be a multi-room chat application that allows a variety of people to connect into it and communicate and enter and exit into different chat rooms. So,
for those of you who aren't happy with how BuzzNet works, here's your chance to go on and improve it.
Actually, I think BuzzNet used to use Photon, now it's using SignalR. But
I thought that was a toothpaste. Anyway.
Okay, so how do we get Photon? Well, we get Photon by downloading it. So if you go to exitgames.com, you want to hit free license download now. Now, let's quickly take a look at the pricing of Photon, because Photon isn't free. Well, Photon it can cost money. So let's look right here. What we have right here are 4 different options of what we can buy Photon for. We have free version, which has 100 concurrent connections, and it costs $0.
CPU being currently connected users, presumably?
Yep, 100 currently connected users. The 500 has 500 concurrently connected users and is only $12.50. 1,000 is 1,000 concurrent connections, has $12.20, blah, blah, blah. Unlimited has unlimited, and it's only $3,500. So the fact is, you can get away with indie development with the free version very, very easily. And
basically, at the point when all of a sudden somebody notices your game, like Yahtzee notices your game and decides to review it on 0 punctuation, at that point, you need to go back to the Photon website and buy the unlimited. Until then,
yeah,
I mean, 100 concurrent users is
a lot.
Quite a lot.
And for unlimited, only $3,500 for server software is not that big of a deal. There's also an indie license. I don't know what their criteria of is. Oh, you're an indie if your monthly turnover is below 10K. So if you make less than $10,000, you can get an unlimited version for $800. So
that's incredible.
That's
incredible.
So the pricing is really, really, really fair. Beyond fair. It's ridiculous. Okay, so they also have this thing called Photon Cloud, which I don't know a lot about. I did some research into it, and unfortunately, Photon Cloud isn't something that a lot of people would necessarily want to use because it is very limited in what you can do.
You don't know a lot about it, but you don't like it.
Well, basically, I think it's great for
well, at least you're honest.
Well, I think it's great for certain types of applications, but unfortunately, it leaves a lot to be desired as far as what code you can execute server side. But it also is also very cheap. However, this is subscription based, whereas this is not subscription based. The difference is when you download this Photon server, you're going to have to own a physical computer to have your Photon server be running on, and you're going to have to pay for all the bandwidth. Now, the Photon Cloud is the other way around, where you rent out their servers for a fairly reasonable price.
As reasonable as it looks, there are some fairly major buts that you brought up on the last version of this class, if I remember rightly. The limitations of it.
It doesn't allow you to run custom code on your server. all application logic must exist on the client, which I find particularly distasteful, but could be very appropriate for simpler games.
Rag said, "Okay, I just bought it."
Okay, so
The thing is, what do you just want to? I mean, because that is a key thing generally when it comes to programming, where things happen. And do you just want to mention that in a bit more detail, please? Because you did on Monday.
well, yeah, typically on a networked application, you'll have an authoritative server which contains all of the game logic and validates that everybody is doing something that's appropriate in the context of your custom application. So it makes it possible for your server to conditionally send certain messages to particular users, depending on whether or not they're authenticated, where they're physically located in the world, and a variety of other criteria. But with the Photon Cloud, the application logic is on the server or on the client, and it makes writing an authoritative server near impossible.
Well, and a big one if you're making anything, dare I say, of those two letters, MMO.
Right.
But as Atomizer points out, prevents cheating stroke hacks.
Right.
Yeah, you're not going to want to be doing things client-side that should be server-side.
Yeah, unless you're working it's complicated, but it doesn't matter. We're talking about Photon Server today. Okay, so what you're going to want to do is go to exitgames.com, click on free license, download now. You're going to want to create an account. I actually already have an account created. And then once you log in or register, you'll get this nice little listing of things. Now, what you're going to want to download is this, the ExitGames Photon Server SDK RC9. You're also going to want to download your custom license. So I'm going to go ahead and click on this. I'm going to download my Photon 3 license, 100 concurrent connections, no expiry, and I had that downloaded. I already have the Photon Server downloaded, so I'm not going to make people wait for that to download. Then you can also download the client SDKs. Now, Photon has client SDKs for Windows Phone, Unity, Marmalade, don't know what that is, Mac OS, JavaScript, iOS, Flash, .NET, Android, and Android NDK, the native development kit for Android.
Are there any particular problems if you've got an old version of Photon installed?
Yes, you'll want the server and the client side to match as far as the versioning. But the ExitGames Photon Server SDK includes the client SDKs for .NET and for Unity. So all you need is this to follow along. Okay, so
Sorry, the server SDK contains...
Yeah, the client SDK.
So... Hey?
Huh?
Sorry, which did you say?
I said the server SDK includes the client SDKs for .NET and Unity.
Right, okay. I was just confused because obviously the Unity one was in that other list there.
Right.
Why would you... I mean, there's going to be people here that use Unity or intending to use Unity.
Right. Well, although Unity and .NET are obviously both based off .NET, you'll always want to use the Unity version when working in Unity and the .NET version when you're not using Unity. And we'll discuss that more once we start talking about what's in this folder.
Okay.
Okay, so the two things that I have right now that I downloaded my license file and my ExitGames Photon Server SDK. I'm going to go ahead and extract this into an arbitrary folder. I'm going to go ahead and extract it under just an arbitrary software folder I have set up on this particular machine and hit OK. And then I'm going to go ahead and say, Photon v3 RC9 just to get the versioning and the pathing. So I'm going to extract that into a nice little folder. And wait a year. Wow, my disk I/O is just horrid.
Are you looking at BuzzNet, by the way? Dane CO Chunji.
Yeah,
I was angling in that direction with what I said about...
Right, you don't need to download any of the client SDKs unless for Unity or for .NET.
No, Dane CO... he's got it now. That's right.
Okay, so when you extract Photon, I just extracted it to an arbitrary folder called software. And you're going to get these 4 folders. Let's go ahead and just walk through these 4 folders. So we'll start with deploy. Deploy contains your applications, your custom applications that you write for Photon, as well as your binaries for Photon itself. Remember, Photon itself is an application that's going to host your custom applications. So you'll have this bin tools, which will include things like Beartail, which we'll be using, which is a log viewer. Other than that, you don't really have to worry about the bin tools. Then you'll have these bin folders. So these bin folders are going to be specific to the operating system you're running on. We have Win32, Win32XP, Win64, and Win64XP. They all contain the exact same things, just compiled for different architectures. Hopefully their naming is fairly straightforward. You'll use bin Win32 or bin Win64 for Vista or 7, and you'll use the XP counterparts for XP. To avoid confusion on my particular machine, however, I'm going to go ahead and delete everything but bin Win64 because I'm running Windows 7 64-bit. So I'm going to nuke.
And I asked you about this the other day as well. Which runs on what? If you Vista, NT, etc. If you think back.
Well, yeah, the bin Win64 XP is for 64-bit XP. Bin Win32 XP is for 32-bit Windows XP, and then the bin Win64 and bin Win32 are for Vista and 7.
But not NT. So
I highly doubt it. I don't know that for a fact. But I highly doubt
right. I thought. My faith in you is completely destroyed. Or not, as the case may be. I thought you said it was there was a cut-off point in terms of backwards compatibility.
Oh, I'm fairly certain there is. I highly doubt.
I don't know where.
I highly doubt that it runs on Windows 2000 or Windows NT or Windows ME or Windows 95 or Windows 3.
Okay. Cool.
It probably doesn't run on Windows 1 either. Okay, so bin Win64. Inside of it, you'll see a lot of things. These are the binaries for running Photon. You'll have a few different little bat files for like service install, service start and service stop, service uninstall. There's two modes in which you can run Photon. You can run Photon as an application or as a service. If you install Photon as a service, it will be like any normal Windows service, and you can configure it to automatically start up when your computer starts up.
Now, sorry, but there may well be people here who don't know what that implies.
Well, basically just don't do it if you don't know what it is, and don't do it if you do know what it is unless you're on a server. Is what it really boils down to.
Actually, delete the following.
Yeah, just don't install it as a service on your development machine. You'll run into lots of fun issues with versioning, and lots of fun issues with your Photon running when it shouldn't be, and you want to do something else with your development computer. However, installing it as a service...
Uninstalling, by all accounts.
Do what?
As well can be. Well, Dane has been having issues. He had to run a command prompt to remove it.
Yeah.
When he was trying to uninstall on a previous version that he'd installed as a service. So
you really want to run Photon as an application, but even then, you do not need to use these bat files because there's a file in here called Photon Control. This little Photon Control.exe will give you a nice little tray icon that'll allow you to control Photon. We're not going to be starting up Photon just yet. The final thing you're going to have to be aware of is the licensing. Photon by default comes with a 30-day temporary license. The license is unlimited except for it expires in 30 days. Now, if you remember, I downloaded my license file from Photon, as should you. So I'm going to move my license file over into my bin Win64 folder and then delete my 30-day temporary license. That's all I need to have Photon pick up on the fact that I have an unlimited license without any expiration that works for 100 concurrent users.
Now, so this is picking up again on sort of implementation details, but obviously you did this last week in the preceding version of this. Have you nuked everything relating to it?
Yes.
I suppose what I'm getting at is with your license file there, you're copying it around, you're downloading it, you re-downloaded it. Is there any restrictions on how many copies of that you can use at once? Say you were working on 4 games.
I have no idea.
But you know what I mean?
I don't know. I don't know if they do any sort of phone home type stuff.
Okay. I just wondered because it suddenly occurred to me when you downloaded it again.
Well, I'm using...
Obviously, you've had that already.
Yeah, I'm using my license on my version on this VM. I'm also using the same license for my host machine, but I never have them running simultaneously because obviously that wouldn't work because they both bind to the same ports.
Gotcha. I was just, me, I'm not a networking guy. And
Okay, so now we have our license installed. This is the main folder that we care about as far as Photon's concerned, because this contains the Photon executable as well as the Photon configuration, which we will be discussing. So if we back up into the deploy folder, the only other folders we'll have in here are things like Content Publisher, Light Lobby, Load Balancing, MMO, and Policy. Now, we're not going to be worrying about Counter Publisher, Load Balancing, or Policy. Counter Publisher is for, performance counters, which we're not going to be getting into. Load Balancing is for, load balancing, which we're not going to be getting into. Policy is for security between Silverlight and Flash, which we're not going to be getting into. You'll also notice that we have these other three folders: Light Lobby, and MMO Demo. Light and Light Lobby are these basic applications that they have the source code for available to you that you can use as a starting point for your programs. We're not going to be using these as a starting point for the programs because that will dilute the purpose of this workshop. We're working with...
Think of those... I mean, I don't know, you can correct me on this, Nelson, as you want to do, but if I get it wrong, but I think of those as very much like Game 1 in XNA. They are something that's there to get you started.
Yeah, and I approach them as...
For noobs, if you see what I mean. They're kind of, use this, press this, they're the make MMO button.
Yeah. I use them for documentation purposes. I think they're nice little programs to look through the source code of. Obviously, in the deploy folder, their source code is not available. These are just the compiled applications. Anyway, MMO...
Yeah, like Musaru said, they're our cornflower blue window. Yeah.
MMO Demo is another application that has basic MMO stuff, interest management, all that stuff. Okay, so now let's jump back into our Photon folder. We have another folder here called Doc. Doc contains documentation. Not surprisingly, read through this stuff if you need to find something out about Photon. This CHM file is... oh great, it's not going to work unless you unblock it. Unblock. This CHM file is generated documentation for all of the types within Photon. So it's a nice little read. The Photon configuration... You what?
I was going to say, is the compiled help... Was it compiled help manual? But what is the CHM essentially what's generated from / comments?
Yeah, that's where all these that's where all this stuff comes from.
That makes sense then. Okay, cool.
So then we have the Photon configuration.pdf. It's a nice little PDF describing all the Photon configuration. Then we have a bunch of other stuff: license terms, performance counters, a README, release history. If you want to look at that stuff, it's whatever, just basic documentation stuff. And then you also have documentation for like the MMO demo, for example, if you wanted to read that. Then we have lib. Lib contains the .NET and Unity libraries, or client libraries for Photon, as well as the .NET libraries for Photon server applications. These are the DLLs or assemblies you're going to be referencing when building your servers and your clients. Source server contains the source code for all of these applications that we saw earlier. So we have Counter Publisher, Light Lobby, Load Balancing, MMO, and Policy.
Do you just want to talk about the concept of load balancing very briefly? We did cover it.
Well,
in the previous one,
kind of. It's kind of out of scope, but the idea is
people
that
will be wondering.
the idea is that you should be able to have multiple instances of a Photon server and have them able to communicate with each other so that they can balance the load of certain types of computation between multiple machines. So that's fairly straightforward. It gets gets way more complicated than that, but
Just a bit, but yeah, it's that's if you're World of Warcraft and you've got a lot of people.
Right, or you have like a huge artificial intelligence simulation.
It's not so much that I wanted you to explain that. It's more that when you say don't worry about this and don't worry about that, I'm if I was just taking the class, I would be sat there going, but why don't I need to worry about that? It's nice to know there's a reason why you don't need to worry about this.
But if you're curious about Photon code, definitely check out Light and definitely check out MMO. So yeah, that's Photon. That's all Photon is. So what I'm going to do here is I'm not going to worry about launching Photon quite yet, because basically when I launch Photon, it's going to launch all these applications I don't care about. I'm going to go ahead, open up Visual Studio, and create a Photon application, and then I'm going to configure Photon to use the application, and then we'll go from there. So let's go ahead and fire up Visual Studio and create a new project.
I'd almost be inclined, I know it's very early, but I'd be inclined to take a short break now, because there's guaranteed to be at least one person who isn't pre-set up and downloaded things that should be.
Well,
and it's quite a natural breaking point before you actually start implementing it.
Yeah, so let's go ahead and pause the video. Okay, and we're back. Okay, so what we're going to go ahead and do is start a new project, and I'm going to go ahead and get Photon working. So bear with the way that I'm going to create this project because of Visual Studio C# Express being obnoxious. So I'm going to create a class library called Photon Test, just Photon Test, which means I'm going to have to go ahead and rename my other Photon Test.
You know what? Puzznet died for me as well.
Okay, so I have my Photon Test. I'm going to go ahead and I'm going to do something weird real fast. I'm going to nuke this project, just delete it, if my delete key works. And then I'm going to go ahead and add two class libraries and one console application. I'm going to write a Photon Test .base. I'm going to write a Photon Test.Server, and these are class libraries. And then I'm going to create a Photon Test.Client as a console application. Okay, I'm going to delete the class ones out of Photon Test.Base and Photon Test.Client and server, sorry, and then I'm going to set my Photon Test.Client as the startup project. Okay, everybody good with this project layout? Photon Test.Client is going to have a project reference to Photon Test.Base. Photon Test.Server is going to have a project reference to Photon Test.Base. Photon Test.Server is going to be the class library that's going to compile into the assembly that's going to be placed into Photon. So we're going to compile Photon.Server, and the resulting assembly is going to be placed into Photon for Photon to run. Photon Test.Client is not surprisingly going to be the client application that we're going to be using. And then Photon Test.Base is going to include base functionality between the two projects, as well as the necessary classes so that both projects can communicate with each other. Okay, so what I'm going to go ahead and do now is I'm going to add the appropriate references. I'm going to jump into Windows Explorer and open up my solution. I'm going to go ahead and add a new folder and call it lib. And under lib, I'm going to add another new folder called Photon. Then I'm going to jump back into my Photon deploy folder, or sorry, my Photon lib folder. So again, remember, this is the application that we downloaded and extracted into a folder. Remember that I have my lib folder. I created that underneath the solution. You'll always want to package your libraries with your projects unless you have a package manager that can deal with that itself. So unless you have something like Rake or NuGet that allows package restore. So you'll always want to carry around all of the libraries that your project depends on within the solution for a variety of reasons, particularly for source control reasons. So I'm going to copy in everything that I need from the Photon R3RC lib folder, which is going to be exagames logging log4net, exagame libs log4net, Photon socket server, Photon 3.net, and Photon host runtime interfaces. These
you just want to hang there with those 6 highlighted for a second and let people make sure they've got them.
Yeah, well, these are the ones, basically everything other than the NUnit stuff and the Unity stuff. Other than that, other than those things, copy everything else over. And so the exitgames logging log for net and the log for net DLLs are for, well, logging. Exitgame libs is for the server. Photon socket server is for the server. Photon 3.net DLLs is for the client, and Photon host runtime interfaces for the server.
Excellent. You fried two people's brains already.
Oh, yeah. Okay, so I'm going to go ahead and get the appropriate assemblies reference between everyone. So Photon test.client is going to have a reference to Photon 3.net and log4net. We're not going to be using log4net on the client, but I like adding the reference in there because using log4net is a very good practice anyway. So I'm just going to add it in there anyway. So I'm going to go ahead and
to be Jason.
Add those references.
And you did that by right-clicking?
Yeah, you right-click, add reference, browse. I mean, it's the same process.
Yeah, I know, but we have to spell it. You have to do it.
All right, so for the Photon Test.Server, I'm going to go ahead and add a reference to lib Photon. I'm going to add a reference to exitgames logging log4net, exitgames lib, log4net, Photon socket server, and Photon host runtime interfaces. So these are the assemblies that I'm going to add into the server. Okay, so like I said earlier, the first goal is to get something of the server working inside of Photon. So what's the bare minimum that we need to do on our server to get it to talk to Photon? Well, there really is one entry point into our application. Just like how our console programs have public static void main, there's also an entry point in regards to Photon, and that's the application class. Now, the name of this class is actually arbitrary. It can be whatever you want, but what?
No, I was literally about to ask whether that was a requirement. I was doing the whole...
Yeah, I personally like it to be called application, but that's just me. It could be anything. The only requirement is that it inherits from application base. Now, application base is a class that's provided for us underneath the Photon.SocketServer namespace, which is provided to us by the Photon.SocketServer assembly.
Actually, do me a favor. Could you get rid of all the usings that aren't currently in use, so that you get...
It's really just...
so that you get them flagged up when you first introduce them, so that you can point them out to people, because otherwise you'll not get... You know what I mean?
Yeah. Okay, so now we have a public class application that inherits from application base. Application base is an abstract class, and consequently we have to implement all of the abstract members. Again, this is the entry point to our application as far as Photon is concerned. These three methods are the most important methods that Photon cares about. We have the peer base create peer method, we have the setup method, and we have the teardown method.
So Photon views whatever it can find that inherits from application base as being like a main, if you like.
We actually tell it explicitly.
Or do we actually have to tell it?
Yep. We explicitly have to tell it which application class to use.
Okay, cool.
But you'll typically only have one per application because there's no reason to have that.
Yeah.
Setup and teardown should be fairly straightforward.
Sorry.
What?
You couldn't make this static then?
No. Because Photon will actually instantiate this class. And when it instantiates the class, it's going to invoke the setup method when the application is started, and a teardown method when the application is ended. The create peer method is interesting because the create peer method is invoked every time a client connects to the Photon server. When a client connects to the Photon server, the terminology you use is a peer. For every connection that the Photon server has with every client, you have one instantiation of a peer. Now
terminologically, this seemed to cause confusion for some people who had experience in other APIs and such, in terms of the word peer being used here.
Well, yeah, it's the...
Do you just want to go just specifically what it means to Photon?
Yeah, for every every time that a client connects to Photon, it will have a peer created for it. So a peer is an object that represents the connection between the Photon server and the client. Remember that Photon is not peer-to-peer. It's not an application where every client connects to every other client. Instead, every client connects to a server. And to represent each client connection, we have a peer class instantiated for every one.
I think that was the part of the key to the confusion. As far as the server's concerned, if it sees a peer, that's the client, or that's a client.
Yeah.
Whereas as far as a client is concerned, a peer is the server.
Yeah,
Yes?
we'll see that once we start talking about it. It does get confusing once we bring in the client stuff.
Yeah, I realise we need to go more into it before you deal with that. But the question comes up now, even though the answer comes up later. If you see what I mean.
Right. Yeah. But as far as the only peer that I'm talking about in this context is the server-side peer, and we'll talk about what the client-side peer means once we talk about client-side stuff. But don't get that confused because it can be confusing. Okay, so the protected override peer-based create peer method is invoked every time a client connects. What it wants you to return is a new instantiation of a class you write that inherits from peer base. So let's go ahead and create a peer class.
Is peer base abstract?
Yes.
Okay. Wick did ask a very pertinent question, actually, which is, he said, I would assume that server-to-server connections, when you're using load-balanced servers and so forth, would also consume a peer connection.
Yeah, I haven't done much server-to-server stuff, though.
But in principle...
I imagine it would.
Yeah.
Okay, so I created a peer class and I named it peer, not surprisingly, and I inherited from the abstract class peer base, and I implemented the only two methods that we are forced to properly inherit from the peer base class. Those methods are onOperationRequest and onDisconnect. Now, it should be fairly straightforward.
Yes.
What both of
We'll
these
deal
do.
with that one first.
OnDisconnect is invoked when the peer disconnects from the server. Now, one of the great things that Photon does for you is it does a lot of stuff behind the scenes to notice when a peer indeed does disconnect. Because with network programming, this is a notoriously difficult problem. When you can't determine if a peer stopped talking to you because he has nothing to say, or somebody tripped over the network cord, or there was a small hiccup on the internet. But Photon has a very good mechanism into detecting when a client disconnects. So when a client does disconnect, the peer that client represents will have his onDisconnect method be invoked. Okay. The onOperationRequest method, however, this method gets invoked every time Photon notices that the client has asked the server to do something. So this is where you put your code that will determine the intent of the peer, of the client, and appropriately invoke whatever server-side logic that you have. Finally, this code still won't compile because peer base actually has a constructor. It does not have a parameterless constructor. So we have to provide a constructor.
Will you not get a warning about that?
You would with once you compile.
3-sharper.
You would with 3-sharper, though.
But in ordinary terms, if you didn't have that there, would that cause an error?
Yes.
Or would it be an exception?
It would be an error. Compile time. Okay, so what do you have? All you have to do is create a constructor that takes in either an init. I like taking in an init request instead of just the protocol and the Photon peer, but I'm just going to take an init request, and then I'm going to invoke the base constructor given the protocol and the unmanaged peer. So that's going to send that information back down into the peer base. So now that we have a peer class, my peer base create peer method can be implemented. When I can say return new peer with this init request. Very straightforward stuff. So these are the two classes, the only two required classes that you have to create. In fact, what I have right here is a valid Photon application.
You could run up Photon and run it, and it would all
Yes, it just
work.
It wouldn't do anything.
It wouldn't do anything. But do you just want to? Sorry, just for clarification, because I know you kind of jumped about it in there in two separate CS files as well. So the file we're looking at now, what happens first?
Well, the application has to. The application's instantiated, and then when a client connection comes in, Photon will ask the application to create it appear, in which case we return a new instantiation. Oh, setup, yeah.
Setup.
The constructor of application is invoked first. Obviously, we don't have a constructor. And then setup is invoked when the application is started.
Right, yeah.
If an exception occurs during setup, the application will not start. I just want to throw that out there. Another thing I want to throw out there, this is actually something that I felt like I might be able to do myself, and somebody asked a question last Thursday, which was a representation of what I thought I could previously do. And when I first saw this, I was like, well, cool. I can have an application that returns a different peer depending on a variety of different conditions. And
so I think that was me that asked the question. You mean like admins and users and... Yeah, that was me that asked that question.
No, I thought it was... But I actually remember the first time I learned about Photon, that was one of the thoughts I had. But then the fact is that if you're thinking that, don't think that anymore, because the fact is, as of the time when you get your init request, you will not have any information to base any particular decisions on as to whether or not this is admin. What you would typically do is return a new peer, and then the peers would make an operation request asking for authentication, and then the peer would do its own thing depending on
yeah, within that it would find out what sort of user you are. And again, I mean, I'm quite well known around the site as being, I'm more of a logic engine than a human being. And yet, still, I was looking at that going, well, presumably, yeah, like you said, that means I can check, I can do admin requests, I can do... But no, because you simply don't have enough information at that point.
Yep. What you'll generally do is you'll have another object model. The peer should be relatively small, and it should defer to another object model in your application that's more appropriate, that will have different classes depending on who you are after you've authenticated.
Right.
Okay. So what I'm going to do next isn't that important. It is really important, but the fact is we're going to be talking about...
Well, no. You can't just skim over that. It's one or the other. This isn't really very important, but it's vital.
Well, yeah.
Don't do it, and no problems will occur, except it will end the world.
What I'm saying is this is not a lesson about Log4net, but we will be using Log4net. So I'm going to start up Log4net, configure it, and not spend much time explaining what I'm doing. Hopefully a lot of it should be self-explanatory, but if you don't quite understand what's going on, we will have Log4net workshops in the future.
This has got to go down as my dumbest pseudo-student question ever, because I asked this in the previous one. It was sort of like, could you get away with not doing any of this Log4net stuff?
Well, you certainly could, but the problem is that...
Man, you'd have to have confidence in your code.
Yeah. Photon applications are headless. They don't have a UI. There's no way for you to know what's going on with your program. The only indication of what's going on in your program is whatever you log out. Logging is typically a very good practice, but logging when working with server-side applications like this is a vital practice.
You will not find, you will hate your life if you don't log things. But theoretically, you could ignore the next, what will end up being about 10 to 20 minutes, and nothing would change, except that if you didn't code it right first time, you'd have all sorts of hell trying to find out.
Okay, blah, blah, blah. Actually, some of these are interesting things that I will be talking about in a second.
Interesting things? Talking about? I thought you only did ponies nowadays. Could I also register Moses' taste for the word configurator? It's horrible.
Blah, 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 blah. No, I don't want configure. I want configure and watch. And then I'm going to say log equals log manager get logger type of application log debug application started. And then finally, the last thing I'm going to do is say, this is going to be fun. Exit games, logging, log manager, set logger factory, log for net logger factory dot instance. Okay, so what am I doing here? I'm just configuring log4net. I'm telling
Can you
log4net.
line, at the very least, line by line through that?
Yeah, so the first thing we do is we say path equals path.combine, binary path, and log4net.config. Binary path is a property on our application base, the class that we're inheriting from. And that is going to point to wherever the DLL is physically located on your machine. And when I say the DLL, I mean the compiled assembly that will represent Photon Test.Server. So it's going to look for a file called log4net.config right next to, or in the same directory of, wherever we compile our application to. Next thing, we get a file info that represents this path. File info is nothing special, it's just the file info from system.io. Next thing we do is we configure exit games. We tell Photon that we want it to redirect all its logging into log4net, as opposed to some other logging framework. The next thing we're going to do is check to see if the file exists. If it doesn't exist, fire up the basic configurator. Even though I shouldn't really even have this here, frankly, it's pointless because there is no console window to print to, but whatever, it makes me feel better. Otherwise, if the file does exist, then do xml configurator.configure and watch file. This is the log4net class that will configure log4net based off our log4net.config file, and then watch it for changes. And if it changes, it'll update its configuration without restarting the application, which is very cool.
Did you do this in the previous?
Yeah.
Am I losing my mind?
You might be losing your mind.
I have no recollection of this whole configurator thing, because it's such a horrible word. I feel I would have registered it. I have no recollection of it at all. It might have been when I blue screened.
Okay. Yeah, well, it's straightforward code. I mean, there's not a whole lot to it.
No, that's cool.
And then we get our logger from log4net, and then we tell our logger to print our application started. There's one final thing I'm going to have to do. I'm going to have to actually create the log4net.configuration file. Okay, this part I'm not going to type out.
Hurrah!
I'm just going to paste it in from this.
Paste? Copy and paste? Surely it's quicker to type it.
Oh, you're funny.
I know. What? Missing resharper, sir?
Well, to be fair, this wouldn't have helped with resharper. Blah, 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 blah.
Or vice versa.
Okay, so what I just did is, this is just a log4net configuration file that I copy and paste everywhere. All it is it sets up two files, a app log and a root log. The app log is going to contain everything that's logged out from my application, whereas the root log is going to contain every warning, fatal, or error that is logged out from anything else. So that includes Photon itself, as well as if I had Enhibernate running, that would include Enhibernate. I like the delineation so that my library code, like my Enhibernate code, my Photon code, doesn't their log entries don't conflict with my own application logging.
I would, sorry to interject yet again, but because there's been a few people who share my kind of viewpoint on this, which is that what on earth has happened? We're looking at XML all of a sudden, we're looking at all this random stuff. This stuff isn't fundamental. This is what I was getting at earlier. This isn't fundamental to your understanding of the actual, what we're dealing with in terms of the Photon and C# talking to each other and getting that set up. This is all about the logging. And the trouble is, it does take in all this. We're suddenly in the world of web stuff almost, and it's just, yeah. Don't get put off by this. Stick with us, is what I'm saying.
Well, the fact is, this and this is the only thing we need to do to get log4net working. After that, we'll be able to use it without any more configuration.
Do you want to? Is there somewhere that, because you cut and pasted that in? Where did you cut and paste it in from?
One of random applications I just navigated to on my computer.
Is this something that what I'm saying is did you cut and paste it from something that you've written before?
Yes.
Or is it cut and pastable from somewhere else?
No, I wrote this at one point a while ago, getting everything configured the way I liked it to, then just kept on copying and pasting it.
I I think you should, and you know how rare this is for me to be kind, but I think you should gist that for people.
Well, yeah, but the problem is I will, but keep in mind that you will have to customize this depending on the names of your assemblies, and you won't know
I'll tell you what,
exactly.
hash out. I was going to say hash out the things that they'll need to change themselves. Sorry to. Do you know what I mean?
Yeah.
This is. Do you not? So I have to remember who I'm dealing with here. Do you not find it any different working? Because you're used to working in like 4 different languages at once.
No, I don't.
This is the hard thing I find hardest. I said this to a few people about the C++ course. So much of my difficulty with the C++ course was down to the fact that I was working in C# all the time. And I just, getting the syntax, the syntheses, getting the terminology straight was a mess.
No, I mean, certainly, but I do come from the web world where I will be slinging around 4 or 5 different languages on any given project.
Yeah.
So
This is not something that we're used to in the world of, people who've come up the way I did via XNA or via just pure C#.
Yeah, but you still will need to understand what's going on with this, where to put it, and all that stuff. But there's a copy and pastable thing for that, and we will be talking about Log4Net in a workshop in the future. But that's not the focus of this particular thing. The only reason I have it here is otherwise we will not get any indication that our program is working when it's loaded into Photon.
Yeah.
Okay, I'm going to add another log instance. When we create a peer, I'm going to say log debug creating peer from, actually I'm going to say debug format, creating peer from init request remote IP. Okay, last thing I'm going to have to do is right-click on log4net.config and hit properties. Then I'm going to jump down to copy if newer for the copy to output directory field. This will make it so when I build, Visual Studio will copy along this file for us into wherever it's built to.
And it's one of those cases where the only one that won't work is the default.
Yeah.
Yeah. Okay. Copy if new is the most optimal. You've also got always copy, which works perfectly well.
Yeah.
And you've got do not copy, which is the default, which will not work.
No. But yeah, obviously, you just have to tell it that. And that's it for Log4Net. Okay. Let's go ahead and get this built into Photon and configure Photon. So how does that exactly...
You
what?
Did you already talk about, the things that they would need to change in Log4Net?
I put a
coming up?
templated variable project name in it.
Oh, okay, cool. Yeah.
Okay, so I'm going to go ahead and let's talk about how you build into Photon. You build into Photon underneath a folder underneath deploy. You're going to have one folder per application you build into Photon. I'm going to call this application 001 Photon Test.
Whoa, he said. You've got numbers at the beginning of your name.
Well, yeah, I just like it. It makes it sort nice.
House style or
yeah.
compulsion?
No, you don't have to do that. That's just me. I like it. Okay, so inside of Photon Test, I'm going to add a folder called bin. This is a requirement. So you'll have your application folder. Underneath your application folder, you will have a folder called bin. This is where you build your server into. I'm going to go ahead and configure Visual Studio to automatically build my server into this folder I created. So you do that by right-clicking on Photon Test.Server, going to Properties, and going over to the Build tab. Now, unfortunately, I'm working in Visual C# Express, which does not support multiple build configurations. However, for a very small development team, it is it's a decent solution to have multiple build configurations, one per development environment and one per production environment. And then the development environments will point their output path to their own local copy of Photon. Now, obviously, this will not work for larger development teams, but it works very well when you have like 1 to 3 people working on a project. However,
was this where I brought up the example of working with Unity last time? I think it clarifies what you're talking about.
Well, yeah,
You know how we've got the MMO set up.
you mean as far as building into Unity itself?
Yeah.
Yeah, you mentioned that.
I just couldn't remember if it was relating to this. And I think now would be a good time to use that as an example.
Yeah, like you can, setting up the output path, you can have it build into any folder that you want. So it's a technique that I came up with when working with Unity was I have a just a normal, straightforward Visual Studio solution that would build into the assets folder of my Unity project. By doing so, Unity will automatically pick up on those DLLs and automatically reference them in your scripts, which is nice, because then you can use things like NuGet and custom project settings without Unity destroying and recreating your CS projects and SLNs all the time.
Does that mean you can also use .NET 4 and so forth?
No. Well, no.
Kind of. Internally you could, as provided you're outputting nothing.
It's really complicated when you get into that.
Oh, is it? That's not on.
But you can compile for .NET 4 and target .NET 3.5 and use .NET 4 features like optional parameters, because optional parameters don't affect the runtime; they are only compile time features. So if you use if you use the C#4 compiler, but you target .NET 3.5, you can use some of the C#4 features.
Yeah, that makes sense. Yeah.
But anyway, I'm going to go ahead and point the output directory of this server into that folder I just created under Photon, which is under my Photon distribution, deploy, 001 Photon test, bin. I'm going to select that folder. I'm going to hit Control-Shift-S to save out this project, and I'm going to hit Control-Shift-B to build it. So when I built this, what happened is you'll notice in my Photon test bin folder, I am now seeing all of my DLLs that I need to work with, as well as my log4net.config.
Do you just briefly want to touch on what would happen if, for the many people who are using the full version of VS?
Well, for the full version of VS, what you would do is you would do what's called a build configuration. I don't know if I can pull up any of these without...
Sorry, you showed this on the last lesson, and I'm kind of trying to match it, if you see what I mean.
Well, yeah, I would pull up one of my Visual Studio instances, but I can't remember what I have. I mean, look at my project names, seriously.
Yeah, because that's my fault.
But anyway, you would go to there'd be a menu item up here called Build, and you go down to Configuration Manager. But that's a little bit out of scope. If I was working in Professional, I would show that to everyone, but because I'm not going to even bother. This will work for a single developer, but it won't work for other developers because your path for where Photon is might be different than theirs. But if you have the full version of Visual Studio, you can use build configurations to deal with that.
Although no, it converts to relative pathing.
Yeah, which is still most likely going to fail.
Yeah.
Okay, I'm going to jump back into my deploy folder underneath my Photon distribution and open up my bin Win64. I'm going to go ahead and actually configure Photon to use my application I just compiled. I'm also going to unconfigure all of the stuff that I don't care about in regards to Photon. Okay, you guys can jump into the Photon configuration.pdf whenever you want to look at some of these settings. I'm just going to quickly go through and do stuff. The first thing I'm going to do is I'm going to disable my UDP listeners. I'm going to keep my TCP listeners because that's the protocol we're going to be using. I'm going to disable my policy listeners. I'm going to disable my WebSocket listeners. And so yeah, so now all we have are our TCP listeners, and that's being provided on port 4350.
Do you want to do an MO collapse comments?
Well, I don't think
I said it the other day, so I thought I'd say it again.
Well, I have to. It gets complicated. Okay, so then underneath the applications. Now remember, I'm underneath the configuration, which is the root element of this XML document. Instance 1, which represents my current Photon instance. And then underneath applications, I'm going to configure my application. But the first thing I'm going to do is unconfigure all these existing applications. I don't want any of them to waste CPU cycles starting up. Okay, so that gets rid of all of the default applications. However, I'm going to go ahead and copy and paste out an application node, and I'm going to change this to reflect my application configuration. So this is where I tell Photon that I want it to launch a custom application. I'm going to call this application Photon Test. The base directory is going to point to whatever folder I put it underneath the deploy folder. So that's going to be 001 Photon Test.
So this should just be a relative path from the deploy folder.
Yeah. The assembly, I'm going to point to Photon Test.Server. The .dll is not necessary. And Photon Test.Server correlates to my Photon Test.Server assembly, which is right here. And this assembly contains my application class. Then I'm going to say the type, the entry point, is going to be Photon Test.Server.Application.
Which is the application class that you've coded up yourself.
Yep. So this is where I tell Photon about my application class. I'm going to leave auto restart as true. I'm going to say watch files DLL and config. What this means is that if a DLL file or a config file is changed on the file system, Photon will restart our application without causing the entire Photon application to restart. And then I'm going to say exclude log4net.config, because I want to be log4net.config is already being watched by my application. If I change this, I don't want Photon to restart my application. I just want log4net to pick up on it and continue to run.
You kind of skipped over enable auto restart and what it does, which should be fairly self-explanatory.
Well, it enables the auto restart.
Explain it anyway.
Enable auto restart just says if any of the watched files changes, automatically restart your application without having to restart Photon. Okay.
And presumably, if there's like a power outage.
No, that would be for
Things
services.
Like that would be.
Yeah, in that case, that's why you want services for server environments, but for development environments is not.
Gotcha.
Particularly important.
Makes sense.
The last thing I'm going to do is I'm going to go ahead and cheat. Because I always forget the stupid attribute name. There we go. I'm going to say restart delay millis is 1 second. Once Photon detects a change, it'll wait 1 second before actually performing the restart.
And this is to stop, obviously, if you had some sort of... I had a really good example of this the other day. I can't remember what it was.
So before we did end this, we removed WebSocket and UDP listeners. Yes. I don't like applications on my computer binding to ports that I will not use them with. So as a result, I unconfigured the UDP listeners, the TCP policy listeners, and the WebSocket listeners. And I disabled these so that they don't bind onto my network adapter. And UDP is for the... what?
I was going to say, if you can answer it quickly, there was a slightly different emphasis on the question in the webinar.
Yeah, I noticed that.
Which is,
okay. UDP listeners are listeners that will bind to the UDP protocol. There's mainly TCP and UDP are the main protocols that you use in network programming. Obviously, this is not an introduction to network programming, so we can't really get into the differences between the two.
That transfer control protocol.
You what?
TCP is transfer something or other.
I can't remember.
The control protocol? I can never remember what they are. Wikipedia is good for that.
Yeah, these listeners will actually bind to my network adapter even if they're not used, so I don't want them there or configured. Furthermore, they also have references to applications that I turned off. So even if I started the TCP policy listeners, but I disabled my policy application, I would get an exception during startup because it wouldn't be able to find policy. And then WebSocket listeners are for WebSockets. And the reason I disabled all these applications is because they take time to start up and I've never used them. And if I ever need to use them, I can always turn them back on. Okay, instance load balancing I'm not going to care about. Instance load balancing can do whatever it wants. Because I'm not even going to be starting instance load balancing. Okay, so now that we have Photon configured, let's go ahead and start it.
Ooh.
I'm going to drag Photon control.exe onto my taskbar. It's a nice little thing to have there for starting and stopping Photon. Then I'm going to run it. I don't know if you guys see the UAC. Do you guys actually? That's a good question. Do you guys see the UAC prompt?
Yeah.
Sweet. It's probably because I'm in a VM. If I wasn't in a VM, you probably wouldn't see it. So I'm going to go ahead and hit yes because Photon starts in the context of an administrative user. And then I'm going to wait for the Photon control tray icon to start up. And there it is.
It makes sense that it starts in admin.
Yeah.
Because, you're dealing with opening ports.
So the Photon control is this little tray icon that you can right-click on and get a menu. I'm not going to go over everything in the menu. I'm just going to go over the important bits. Photon Instance 1 is your Photon Instance 1. It's the instance we just configured with our application. The only important button here is Start as Application. That will start Photon Instance 1 as an application and not as a service. When starting as an application, we'll have a lot more control over starting and stopping it, as opposed to it being a service where it gets all integrated into the operating system and all that stuff. So I'm going to go ahead and click on Start as Application. Start as Application just defers to another program, and I'm just going to go ahead and say, don't always ask me before opening this file, and I'm going to hit Run. Now I'm going to right-click back on the Photon control, and I'm going to say Open Logs. Open Logs is going to open the Photon logs that we can actually watch and make sure that Photon starts up. If Photon fails to start up, this is where we know. As you can see, we already have an error. It says shutdown complete on this Photon instance log, which means that, well, it didn't successfully start. So let's look up and look for the first error. So we get an exception right here, and it says unknown application light. The reason we're getting that is because I completely forgot to set the default application to Photon test on my configuration. Because I disabled light. Obviously, light doesn't exist and didn't know what to do. Okay, so let's try this again and see what happens. I'm going to right-click on the Photon control, go to Photon Instance 1 and hit Start as Application, and I'm going to watch the logs.
Hurrah.
All right, and we get a successful startup. As you can see at the bottom, it says service is running. So let's go ahead and...
I notice it also confirms all the config things that you set up,
Yep.
like application will restart 1,000 milliseconds after the last change and blah, blah, blah.
Yep, and it also tells us what adding TCP listener, blah, 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 and so on. Okay,
Sweet.
So you'll notice that the way that I have... here's a very important aspect. There's two logs in Photon. There's the Photon instance log, which is primarily the native code for Photon. Photon is not a .NET application. It is a native application that spools up a Microsoft CLR to run your code in. This contains all of the native log entries for Photon. The Photon CLR log obviously contains all of the .NET CLR entries. And you'll notice something interesting. We create the Photon test application domain. We're not going to be covering application domains. That's a .NET feature, but just bear with me for a second. And we specify that the application base is underneath C software Photon v3 rc9 deploy. That means all paths inside of my application are relative to this deploy folder, which is why when I set up my log4net.config, I didn't just do log4net.config, I said combine binary path of log4net.config, because the working directory of the server is not in the bin folder. It's in the deploy folder. The reason I'm saying this is that has one interesting implication, and that is my log4net.config is configured for a relative pathed log file underneath a folder called log. So you'll notice that a folder actually appeared underneath my deploy folder called log. And underneath log, I have my Photon test app log and my Photon test root log. So I'm going to drag these both into Beartail. So I'm going to drag both of these into Bear. So So I'm going to go ahead and hit open, and there they are. And open these two logs. And you'll notice that right here, Photon test.app.log has application started in it. That is how we know that this line of code executed. Alrighty, so I think it's about time to go on break. We've set up quite a bit, actually. We've got Photon all configured. We have an application, and the application is actually running. Obviously, we don't have a client yet, nor do we have any application logic, but that's going to be the next bit of this workshop. So I'm going to go ahead and pause the video. About now-ish, we're back. Okay, so question, what could be caused that a log file was not generated for Photon test.application? Well, either you did not configure log4net properly or your application did not start. Check your Photon instance log and your Photon CLR log, make sure the service is running, and verify that your Photon application is configured. If your Photon application is configured, as in you see something like about to load application Photon test from Photon Test.Server, then check your log4net configuration. Make sure that you have this code represented in your setup, and make sure that you have your log4net.configure file appropriately being copied into your folder. But we have a lot to cover, and so I don't think we can spend a lot of time debugging that. But those are the two problems that you might be running into. Either you didn't configure it right, either you didn't configure your application, the Photon server didn't start, which you said it was started, so that means that it's probably you didn't configure log4net right. Notice that I have a not file exists here. I know I did that backwards for some reason. I probably wasn't thinking straight. It really should be if file exists, then do the XML configurator, otherwise do the basic configurator.
You were probably only thinking as far as making sure that you had the basic one backed up in there.
Yeah, but
You changed your mind halfway through. Went, oh, I'll stick an else in.
okay, so let's go ahead and create a client real fast. So I'm going to start off with, so here's our client. We have a class called program. I'm going to go ahead and start off with a class that I like creating called server connection. My server connection class is a class that I typically use as an abstraction over the Photon client interface. So I'm going to have it implement something important. I'm going to have it implement iPhoton peer listener.
And would this be why you implement it over the top?
Why, what?
You said this is something that you implement over the top of.
Yeah, my server connection is typically what I use as a basic abstraction over the Photon client code. And it'll become very important later on as our client framework matures. It's going to take in a string IP address and a string application name parameters. And it's going to alias those out into fields. Okay, so
finally some code I can understand.
Basic, straightforward stuff. This class is going to wrap over Photon. Why abstract Photon? Isn't it already an abstraction over WinSock? Well, yes and no. You will need at some level. Well, let's back up really quickly. I'm going to go ahead and write out some more code, and hopefully it'll become a little bit more apparent what's going on.
That's kind of what I was getting at when I was asking about why was it the implementation of iPhoton peer listener that was why you were doing it, or is there more to it?
Well, you'll see where I'm going with this very shortly here.
I've seen where you're going with this already.
Okay, the fact is, so we did have a question coming in, like, why do this? Why have this extra class wrapping around our Photon connection? And the answer is simple. The Photon peer class is, when we're talking about the client side, the Photon peer class represents the client's connection to the server. It is the other end to the peer class that's on the server. So the peer class communicates with the Photon peer class. This abstraction that I built only exists because we need to pass in what's called an iPhoton peer listener object into the peer when we instantiate it, as you see on line 19. This interface forces us to implement debug return, on event, on operation response, and on status changed. This is how Photon talks to our application. Now, I really do not like the idea of Photon being in existence everywhere within our program. This class is responsible for talking to Photon, not in an abstract way. So when I say the word abstraction, don't think that I'm going to be building some super abstract mechanism for communicating to Photon. But instead, this is the class that's going to handle the serialization and deserialization of our data. It's going to parse out the intent of Photon, and it's going to appropriately talk to the rest of our code.
This is going to be the thing, essentially, that enables the rest of our code to get on without knowing about Photon.
Right. And,
yes?
Yeah, and you need it anyway. Well, it is encapsulating Photon, but we will be providing a small level of abstraction a little bit later, which will be discussed. But the fact is that you need a class like this anyway to work with Photon. That's how Photon works. And I like keeping in the only code that needs to know about Photon inside of this one class on the server side.
When you say a class like this is required, what do you mean by that? A class that implements iPhoton peer listener?
Yes.
Or... So, right, okay. It's just a very non-specific thing to say. Some sort of class like this is required.
So let's go ahead and use this. I'm going to say var server equals new server connection 127.0.0.1 colon 4350, I think. And we're going to connect to the Photon test application.
Photon.
Then I'm going to say server.connect, and then I'm going to say while not console key available, server.update, thread sleep 10, server.disconnect.
But, like, Nelson, dude, what if I don't want to connect to, like, 127.0.0.1, like, dude?
Well, yeah, this is going to be the IP address and port that we connect to. This is going to determine what Photon server we connect to. 127.0.0.1 is the loopback adapter. What I mean by that is 127.0.0.1 will always point to the computer that you're working with. The colon 4350 is specifying which port. If you remember in the configuration, 4350 is what we configured Photon to listen to on TCP. And then the Photon test is the name of the application we want to connect to. Now, there's nothing, typically what you would do here is you would connect to a domain name. And then DNS would simply resolve the domain name depending on what server you're connecting to, and so on and so on. The mechanism in which you get your server address is completely up to you. I'm not going to be getting into too much depth about that. We're simply going to connect to our local server. Then we're going to say server.connect. This method simply defers to the peer.connect method. And then we're going to say, we're going to open up a loop. And while we don't have any keys available in our console input, we're going to say server.update. Server.update simply defers to peer.service. The peer.service method is what's going to, basically that's the main loop for Photon. That's what Photon's going to use to determine if there's anything that Photon needs to do for this particular invocation of peer.service. So does it need to send information? Is there information waiting to be received? What are we going to do? Blah, blah, blah. So at some level, you have to invoke the peer.service method in a sort of loop. And then when there is a key available, I'm simply going to exit the while loop and say server.disconnect.
Can you just say a little tiny bit more about key available?
Oh, well, key available is just a Boolean that indicates if there's a key press available in the input stream.
So essentially whether there's not a key down.
Yeah. Okay, so let's...
As opposed to a read key.
Yeah.
Because...
Because a read key would block. We want this code to continuously loop. And then we sleep 10 so we don't take up 100% of our CPU. Okay,
Cool.
so when I run this program, you'll notice something interesting.
Is that a promise? Or is that a magic trick?
There we go. I got a slight dyslexic moment. It wasn't 4350, it was 4530. So now you'll notice in our logs, it says creating peer from 127001. Well, where does that code come from? If we look at our application class, it says right here, whenever a peer create happens, we say creating peer from remote IP. And then I can do the opposite in the peer. I'm going to go ahead and get myself a log here. I'm going to say private static read only ilog log equals log manager dot get logger type of peer. And then when I say on disconnect, I'm going to say log debug format peer blah is leaving. And then this is going to be simply remote IP. So I'm going to go ahead and Control-Shift-B this. When I Control-Shift-B this, when I build this solution, Visual Studio will copy in the build artifacts into my Photon application, which will trigger an application restart. And then I wait for my application started log message to appear to know that my application has successfully restarted. So now when I run the client...
You'll get all sorts of failures if you forget and try and run it.
So now I'm going to hit F5, and you notice we get creating peer from 127001, and then I'm going to hit a key, and now it says peer 127001 is leaving.
Very nice.
Okay, so
I was going to say, any questions up to this point? Because, I mean, that seems to me we've got the most basic of things in place. And if you've got questions for us, can you please put them in the webinar questions panel? Save us sifting through chat.
I take it that since peer is on the server side, that's why you're using remote IP. Yes, this particular peer is on the server side. This is every instantiation of this class represents a server's connection to a client. Okay, so let's go ahead and run through a bunch of code at this point, or let's take a step back and talk really quickly about how I'm going to go ahead and organize my code. What I'm going to do is create two very basic things: events and commands. And this is a very common pattern in the .NET world or in the programming world in general. The idea is that every peer can send any command to the server, and the server can send 0 to many events back to the peers that need to be updated about what's happening on the server. So let's start with our commands. Now here's the important aspect. When I send a command to a client, what's a command going to look like? Well, let's go ahead and code up a command real fast. A command is simply going to be a DTO that happens to implement a particular interface. I'm going to create a namespace underneath my Photon test.base project and call it commands. And I'm going to create a basic command here. Let's make a login command. Very straightforward command.
And a logical place to start.
So what is a command? A command is basically any of these DTOs that implements the iCommand interface. Now there's nothing special about what a command is. It's just a DTO. It's just a data transfer object that contains data that we can package up and send. So I'm going to go ahead and give it a constructor of string username. I'm going to go ahead and have that set to a property with a private setter. So the way I've organized the system is that we have these commands that just contain data. We instantiate the commands on the client side, we serialize them, and then send them to the server. So it's very relatively straightforward stuff. And then the server reconstructs our commands, identifies which command is which, and invokes specific domain logic depending on what command was sent in by which peer. So now let's go ahead and jump all the way back into, I'm going to create one more abstract type. I'm I'm going to create a type called an iCommand dispatcher. The only reason I'm creating this type is for a level of cleanliness as we move forward. You don't necessarily have to understand why I have this interface right now. It's just a matter of cleanliness that will hopefully come into focus when we move on with our code. So we need to be able to send a login command to our server. How can we do that? Well, I'm going to have my server connection. Remember, this is the client side. This is the client-side representation of the server. I'm going to have the server connection implement a iCommand dispatcher. Just for now, it's not necessary that I do this, but when I start passing my server connection around into other once I start passing this object around into other aspects of my program, I only want other aspects of my program to see my server connection as a command dispatcher. I don't want them to see other methods like connect, disconnect, or update. So that's why I hid it behind this interface. So what's the dispatch command going to do? Well, it's going to serialize my command and send it to the server. We do that with the peer.op custom method. The peer.op custom method is the method that we use to tell Photon that we want to send information from our client to our server. And it takes in 3 important parameters. I mean, it takes in a few more depending on what you're doing at different overloads. But the overload we're going to be using takes in 3 important parameters. First of all, it takes in a byte called custom opcode. We're going to be ignoring this right now. The custom opcode is simply a byte that's packaged along with every operation we send to our server that we can use to differentiate between what commands are what. We're not going to be worrying about that right now. Instead, we're going to be worrying about the custom op parameters, which is a dictionary of byte and object. Finally, the last parameter is send reliable. I'm going to say true because I want Photon to send this in a reliable fashion. If we're talking over TCP, that's fine because TCP handles reliability at a protocol level. But if we're talking over UDP, we want to make sure that Photon does a little bit extra work to make sure that the UDP packets arrive appropriately. Okay, so now we need to talk really quickly about serialization. Serialization is the idea of packaging up data into a format that can be later reconstructed on the other side, whether or not the other side is a file, database, or network stream. You can use the built-in Photon serialization. Unfortunately, we don't have a lot of time to cover that code right now. It is decent and it does work to an extent, but is kind of limiting. What instead we're going to do is we're going to serialize our commands and events as JSON and send them over the wire. Now, a person might say, well, why are you sending it over JSON? Doesn't that take a while to, a relatively long amount of time to construct, and doesn't it add in a bunch of additional bloat that we wouldn't want if we were building an FPS? And the answer is yes, it does. But it's easy, and it's something that we can use to actually make a working application within this short time constraints. If we had appropriately implemented serialization, it would have taken a lot longer. That is a topic that is something that's going to be specific to every single application you write, is going to have its own serialization requirements, and it's a topic that has a lot of things to discuss about it. But for right now, I'm going to
in a bandwidth intense world, you're probably going to be using binary.
Yeah, you're going to be using some form of binary
is the short answer.
Something like protobuf or something like that. You would not be using the built-in .NET binary serializers because they kind of suck. You would be using...
Presumably that would cover things like RLE and stuff as well.
You know what? Oh.
Or not? Would that cover RLE being used as well or not, really, for those sorts of cases?
I'm not familiar with what the words...
Run length encoding. Run length encoding. Is that inappropriate for this sort of thing?
I've never played with that.
Oh, okay.
But yeah, there's a variety of different encodings you can use. But that's something that you're going to want to have to look at yourself for your own application. I'm going to be using JSON particularly because the JSON deserialization library that I'm very familiar with handles a lot of situations that makes it working with it very easy. But that's not something you would want to do for a high-performance application. I mean, I just want to point that out really quickly. However, it's more than appropriate for a thing like a turn-based game or a chat-based game or, console text-based game, stuff like that. Alternatively, you could write custom serialization logic for every command that you want to send. However, that's going to get old very, very, very quickly. In fact, that's what I started off when I was working on putting together this workshop. I was like, I don't want to introduce JSON.NET because that's kind of out of scope. So I'll just use the built-in Photon. Oh, this is taking forever. So
I want my life back.
Okay, so I'm going to cheat really fast and use JSON.NET. JSON.NET is a nice little library that I've already downloaded and placed on my desktop. And the reason I had to download it and place it on my desktop is because you would typically get this package out of NuGet, the .NET Package Manager. Unfortunately, Visual C# Express does not support NuGet, so I'm going to have to manually grab it and dump it into my lib folder.
If you are using the full version of Studio, then go up to your... I can never remember what the main menu is, but it's in your extension manager.
Yeah, that's how you get NuGet. If you already have NuGet installed, you can just right-click on your references and say Manage NuGet Packages.
Yeah, but you've got to install NuGet in the first place.
Right. So
you go up to Extension Manager and dig around for NuGet and then install it via that, and then you'll have NuGet and everything will be shiny.
Yep. So yeah, so now we have JSON.NET moved over into our project, and we're going to be using this for serialization for now. So I'm going to go ahead and add a reference to JSON.NET. And yeah. So when I dispatch a command to the server, Photon expects that we pass things in a dictionary of byte and object. So I'm going to first pass in, as the first item in the dictionary, I'm going to say command.getType.assembly qualified name. As the second parameter in our dictionary, I'm going to say JSON convert.serialize object command. This is going to send this data to the server. It's going to send the name of the type for the command and the actual JSON data for the command. So now let's jump back into the server and actually deserialize this. So I'm going to go ahead and jump into the peer, and whenever we invoke peer.opcustom, inevitably what's going to happen is that Photon is going to send a command to or message to the server and then deserialize it to an extent for us and then invoke our corresponding peer objects on operation request method. We can get, through the operation request parameter, we can get the operation code, which is a byte, and the parameters, which should look familiar. It's a dictionary of byte and object. So this is the code that Photon's going to invoke when our peer asks Photon to do something for us. So when we say peer.opcustom, after Photon does all its magic, dispatches the message over the internet, we will end up on the server side inside the onOperationRequest method. So let's go ahead and deserialize our command from here. I'm going to say var command equals iCommand. You're not going to, are you? You really want to do this?
That's funny. Qualify it.
Oh, hold on, I forgot to, no, I do have a reference to base. Oh, you gotta be kidding me. This is the first manual using statement I have placed in code in a very, very long time.
This is a rare thing.
Ugh. Okay, so, I'm forgetting equals there as well. That's actually probably
why then.
Probably because I didn't have the equals there. Visual Studio didn't pick up on me trying to import something.
Yeah. For some reason, it wouldn't let you do something that's not possible.
Okay, so I'm going to say iCommand JSON convert, and I'm going to have to go ahead and import JSON.NET into my server. So I'm adding a reference to JSON.NET. Deserialize object, and then I'm going to pass in as the first parameter. I'm going to say operation request parameters 1, and as the second parameter, I'm going to say type get type string operation request parameters 0.
Now, I know I didn't specifically mention this the other day, but that's really a silly way of going about things. and I can't quite work out why they did that.
How do you mean?
That you need the first parameter second.
Well, that's my fault, because I sent in the assembly.
Ah, well then you're a fool. It bugged me the other day, but I didn't bring it up. Because every time you got to it, there was even a point where you put it in wrong and then had to change it.
I don't know. It makes more sense for me to pass in the type before the data. But when we invoke the deserialize method, we have to pass in the data before the type.
Okay, I'll let you off.
Okay, so hopefully people can see the correlation here. When we invoke the dispatch method of our Photon test.client.server connection, we invoke the op custom method of the server's peer, the peer that represents the connection to the server. When Photon gets done doing all its magic, we end up on the server side on this method, where we do the exact opposite. We deserialize the command into a fully fledged .NET object, which is going to be, in this case, a login command. So now what I'm going to do, I'm going to say try catch exception ex blah 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 error format command blah failed command get type name ex. Okay, so if there's an exception dispatching the command, we catch that, we log it. Otherwise, I'm going to say try. The first thing I'm going to do is I'm going to do log.debug format command blank executed. And then I'm going to say command get type name. Now I'm going to introduce a really quick little bit of syntactic goodness. Don't have to understand exactly what I'm about to put together, but I'm doing it just to save a lot of typing. I'm going to go ahead and create a private read-only dictionary. Oh, come on. Really?
I think you need to get the angle brackets in a minute.
There we go. I had to get the angle brackets and a comma in. I'm so not used to ReSharper. Okay, so we'll have a dictionary of type and action I command, and we'll call these command handlers. Then I'm going to instantiate command handlers.
Now, what exactly is going on here?
Well, I'll say in a second, because this is important stuff. Or not particularly important stuff, but interesting stuff regardless.
For anyone who's in the earlier lecture,
Yeah.
here have a lambda. No, in fact, atomizer just put action. That relates to delegates. Yes, indeed.
Okay, all you need to understand about this dictionary is that this dictionary relates a... oh, shut up. This dictionary relates a command type with a bit of executable code that will be invoked whenever the command is received. That is all that's important to understand about it. So when I do command handlers, command.getType, invoke with command, this code on line 39 will invoke whatever bit of code that I've registered to be invoked when this particular command is received by Photon. An action that relates to delegates, yes, this is a delegate.
And again, because I pointed out this out the other day, this particular bit of syntactic goodness, as you put it, it always sounds like a breakfast cereal commercial whenever you say that. But they're great for other things as well, like, for instance, hotkey management.
Yeah.
I'm just going to throw that out there because I beat my head around it and I don't want to give too many clues away because everyone else must suffer, like I did. But yeah.
It's not important to understand. What it is important to understand that when line 39, when we receive a login command from the client, this code on line 28 will be invoked. Okay, so that's it for the server as far as the login command. Let's go ahead and dispatch the login command. Now we have an interesting problem. This is important to point out to people who work in Photon. The fact is that Photon will not actually end up connecting to the server until an undefined amount of time after we invoke the connect method. Which means that if I were to dispatch the event or the command for logging in after we invoke server.connect, there's a chance it might not go anywhere because, well, we're not connected to the server yet. So how do we detect when we really actually for real connect to the server and can start talking to it? Well, the answer is fairly straightforward. You'll notice that the iPhoton peer listener interface includes a method called onStatusChanged. This method will be invoked when we properly connect to the server. So as just a way to test this code to get something working, I'm going to say if status code equals status code.connect, then dispatch a new login command.
Could you just go to the dot tooltip for status code?
Yeah, there's quite a few different ones. Connect, disconnect by server logic, by user limit, encryption established, encryption failed to establish, exception on connect, internal receive exception, queue incoming reliable warning, queue incoming unreliable warning, queue outgoing ACK warning, queue outgoing reliable warning, queue outgoing
every single
warning.
one, but just a general idea of what was in there.
A lot of stuff.
Any key things?
Okay, so what I'm doing now is I'm simply writing a little bit of code to say when we for real connect to the server, when we get the onStatusChanged method invoked and we actually connect to it, dispatch a login command. So I'm going to build my server. I'm going to fire up my logs real fast. Wait for my application to say it's been started, which it now has. And I'm going to run my code. Notice how we get this. It says creating peer from 127001, login command found, command login command executed, which is exactly the code that we put together in our peer. We say when a login command happens, debug out login command found, and then after a login has been, or a command has been successfully executed, say that command X has successfully executed.
Can you force a failure?
Well, yeah, if we wanted to.
Can you force that catch block to throw, just to see what happens? Oh, well, yeah, that'd do it.
Okay, so after we debug log out this, I'm going to throw a new invalid operation exception. Let's wait for our application to say it's started. It is started. Let's run our application and see what happens. Notice how we say login command found, and then all of a sudden, command login command failed. System.invalid operation exception, exclamation point, exclamation point, exclamation point, exclamation point, exclamation point, exclamation point, unsmiley face. So fairly straightforward stuff.
Nice. It's always helpful when there's going to be some sort of 3-line long error to see what it is.
Okay, so let's make things a little bit more interesting. I'm going to dive really quickly in to, I'm going to be putting together a very basic client-side application framework, because what we have here essentially already, actually, no, I'm going to back up. Remember how I talked about how we have two sort of types of DTOs. We have commands and we have events. Commands are sent to the server, whereas events are sent from the server to the clients. So let's go ahead and create our iEvent interface, and let's create an event. Now, the reason I have the iCommand and iEvent interfaces isn't so that I'm putting anything in there, really. I mean, sometimes I'll put like a date time created at in there. Sometimes I'll put in like a UInt account ID or something like that. But typically, I just leave these blank. I use these simply to annotate the DTOs as either an iCommand or an iEvent, so that when I have other interfaces, such as the iCommand dispatcher, it makes sure that whatever we pass into the dispatch method is something that we've purposefully annotated as implementing iCommand.
So you're just using it as like a shibboleth, a password,
yeah.
Almost. If you're not in the club, you're not coming in.
So now I'm going to go ahead and create an iEvent publisher. Notice the different terminology. An iEvent publish, we publish events and we dispatch commands. Also notice how I'll be doing this a lot. The fact is, event is a C# keyword and must be prepended with the @ symbol to work. Now I know some people personally don't like that and they would rather see code like EVNT or something like that, but I hate that. I just like doing
Or
that.
just my event would do.
Yeah.
Because I kind of feel I'm with you on why it should be called event, but equally I hate using the literal symbol.
I just got used to it somehow. I've typed in so many event-based systems that.
Yeah, but you're the guy who came up with this equals that. So, you know.
Well, of course.
Anyway.
Okay, so yeah. So now let's go ahead and create an event. Now, these events and commands I've already decided on. Events and commands are basically going to be application specific. These are not application in specific commands and events. As your application grows in complexity, you will have a lot of more commands and events representing the different things that you can do with your application. So I'm going to go ahead and create a new event called logged in event. The logged in event. What?
I thought you were typing. I was just going to mention that Brian was asking about the @ symbol. He said, "Wait, @ is legal in an identifier?"
Yes and no. It's illegal in an identifier, but if it's prepending an identifier, then what it does is it allows you to have your identifier conflict with a keyword of the language.
So that could equally be @ class.
Yes.
For instance, just tells it you're doing something stupid.
Yep. So I'm actually, you know what I'm going to do? I'm going to go ahead and write all of my commands and all of my events just up front. Because I think that any system that's architected like this, you should be able to look at your commands and your events and have a good feeling for how the system should progress. And if I do this now, it'll save a lot of time and it'll give people a perspective of where I'm going with this application. So the first thing is the logged in event. I'm going to create a value object right now. The value object I'm going to go ahead and create is going to represent a player. And also this should be events, not event. Okay, I'm going to go ahead and create a player details. What's a player details? Well, a player details is going to be an ID and a name. Every player has a GUID ID and a string name.
Everything in Nelson's world has a GUID ID. His fridge has a GUID ID. His desk. Everything.
Well, you have to. It's the only way.
I just remember a conversation with you at one point where you just like the very idea of something not having a GUID ID was just complete anathema to you. You couldn't understand the concept.
Yeah. Okay, so now we have our player details value object. When we log in, so when the logged in event happens, this event is sent from the server to the client that successfully logged in. And he's going to receive a player details.
Casing.
No, it's lack of resharper. Okay, so our logged in event, when the client receives a logged event, he knows he successfully logged in. So the opposite of that is a login failed event. So I'm going to say login failed event. I'm not going to worry about putting anything inside of this event. It's just going to say login failed event for whatever reason. If you guys are implementing the system and you want the server to be able to give the client a reason why the login failed, then you are more than welcome to do so.
This is where you would have the code that says you have got caps locked down or you have not bothered to put anything in the password field and so forth.
Right. Okay, so what other commands do we need? A funny thing, we only want 2 more commands with the system that I want to develop today. We want a join room command. So when the client wants to move to another room, he's going to tell the server to place him into another room, and that room is going to be identified with a room name. Very straightforward DTO. We just have a room name. The final command that we want in our system is to send a chat message. So I'm going to say send message command. All the send message command is going to have is a string message. Oh, I just hit Alt-Enter. That makes me sad. Okay, so these are our three commands: join room, login, and send message. That's all our clients can do to our server. And we represent these different intents with simple DTO objects that are going to be serialized and sent over the wire. Now we need a couple more events. We're actually going to end up with quite a few more events than commands. The first most important one is going to be something like we need, basically, think about it this way. We need to be able to tell a user who just joined a room what room he joined and who else is in the room with him. So we're going to have a room joined event. Our room joined event is going to have a string room name and an IEnumerable of player details for current players. I don't even know. I don't even know why Microsoft doesn't just buy JetBrains and integrate ReSharper into Visual Studio. Okay, so our room joined event is going to be sent to a person a client who just joins a room, so that he is made aware of the current state of the room that he's now in. However, there's three more important events that we need. The first event that we need is going to be a player, or I'm going to say player entered room event.
Is this what other people see?
Yeah.
That who are already there?
Other people, so a person who just joins a room is going to get a room joined event, but a player entered room event is going to be fired for everybody already in the room. This is only going to contain the information that has changed since they joined the room initially, which is currently just going to be player details, representing the player that just joined.
You should know. You've got to implement an I am not a bot.
Also notice how I've been forgetting to implement iEvent on these events. Thanks everyone for paying attention. Okay. Okay, so now we need a player left room event. And people might be looking at this and saying, wow, you're being really verbose. Well, how else are you going to be representing this stuff? The fact is that using a DTO-style event messaging system is typically going to be more succinct than any other serialization framework that you can possibly even imagine putting together.
Could you not use, like, I don't know, some static globals class and then some actor-based hierarchies?
I don't think that would be
Through
necessary.
inheritance. Do you not?
In fact,
for why?
I don't think that any inheritance is necessary other than what's required by Photon.
And for anyone who doesn't, please ignore me. I was just talking while he was typing.
Okay, the final event that we need is a message sent event. This will be sent to everybody when a message is, well, sent. It's going to have the GUID player ID of the person who said it, the message, and the date time of when it was sent at.
And remember, this system doesn't implement targeted, like private chat between players. Although that would be an easy.
Yeah.
once you finish that would be an easy add-on to do. So that player ID there is the person who said the thing.
Yep. Okay. That pretty much wraps up our base project. This is really the only things that we need to have to represent our entire system. These are the only aspects that need to be understood by both the server and the client. There's a few important things about our commands and events. First of all, notice the language and the tense of, I don't even know what grammatical attribute I'm trying to represent here with my words, but notice how each one of these commands say stuff like join room command, login command, send message command. We're joining a room, we're logging in, we're sending a message. Whereas the events are the reverse. Right. We have logged in, or our login has failed, or a message has been sent, or a player has entered a room, or a player has left, or a room has been joined. That sort of language is very important to be consistent about.
It's basically in commands you're using first person. You're saying I am going to join a room, I am going to log in. Whereas in the events they're third person. They're referring to somebody else saying a room has been joined, a player has left a room.
Right.
Gavin says that's what he means. Sorry, it gets weird then.
Command. Time to use reflection to auto build our dictionary. No, I'm not going to.
Don't tempt it.
Yeah, I'm not going to do that. I'm going to go ahead and
without resharp.
I'm going to go ahead and implement all of my command handlers right now because there's only 3 of them. All my login command, our join room command, and our send message command. And then I'm going to say blah 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 blah, and then I'm going to say blah blah blah. Okay. So now I've wired up all 3 of my commands. So these methods will be invoked when a command is sent from the client of a particular type. Not only that, if we look at the command, we have all of the properties that were serialized and sent over the wire. So now let's go ahead and hook up our events. Because we've talked about commands, but we haven't hooked up our event system yet. The first step is I'm going to go ahead and on my peer itself, I'm going to have my peer implement iEventPublisher. Notice this is a very interesting thing to note. Our server connection implements iCommandDispatcher because our clients dispatch commands. Our server peer, though, implements an iEventPublisher because our peers publish events. And it's the same sort of concept. I'm hiding it behind an interface because I want my other code within the system to be able to send events through my peer, but not necessarily know everything else about what a peer is. I'm hiding everything else using an interface. So I'm going to go ahead and implement the publish method. The publish method is going to be very, very straightforward. In fact, our publish method is going to look very similar. There's a method on the peer class called sendEvent that takes in an iEvent data and a send parameters. Although it looks slightly different than our op custom, it's actually very similar. So what I'm going to go ahead and do is I'm going to say log debug format publishing blah to blah event get type name remote IP, and then I'm going to say send event new event data. I'm going to pass in a event code of 0 because I'm not taking advantage of event codes or operation codes. Then I'm going to pass in a very familiar dictionary, a dictionary of byte and object. After my dictionary of byte and object, I'm going to close out the event data constructor and then pass in some send parameters. The send parameters I'm going to pass in is simply going to be the default, but with unreliable set to false, because I want this to be set reliably. So what goes in here? Well, what goes in here is basically the exact same thing we had in our command dispatcher. The difference is instead of sending a command from the client to the server, we're now sending an event from the server to the client. So the first member of this dictionary is going to be event get type assembly qualified name. And the second parameter is going to be JSON convert dot serialize object event. And that's that. Now our server code can appropriately send events back into our client. So let's talk about how we can actually take our clients and have them be notified of when an event happens. Well, things are going to get a little tricky at this point. And the reason they're going to get a little tricky is because I'm going to introduce a very basic abstraction, a very basic piece of architecture so that our client code is manageable. Now, I didn't want to just show people how to use op custom and send event. I wanted to show people a realistic application that has a realistic architecture to it. Although it's very, very simple, it still is something that's fairly realistic. So I'm going to go ahead and create an abstract namespace in my client. I'm going to create a few different types in it. I want an iController. What's an iController? In this particular instance, in this particular architecture, an iController can do two things. It can handle an iEvent, and it can process input. Then I'm going to create another abstract type, or another interface, sorry, called iEngine. Our engine is going to be very straightforward again. It's going to have two methods on it. We're going to be able to switch the active controller. So we're going to be able to say, okay, I want this controller to be considered active right now. I want this controller to receive all the events and all the input instead of another controller. It's also going to have a quit method on it to quit the application. So those are our two little abstractions that we have inside of our client. Now I'm going to go ahead and actually create an implementation of the engine class. This is where things are going to get a little crazy. Here's what I want.
Because so far it's all been incredibly straightforward.
Well, here's what I want. I want an engine class that can handle a connection to Photon transparently and also be able to activate a particular controller. And I also want any input that comes in through the console to be sent to the active controller. And I also want any event that the server sends us to be published to the active controller. So at that point, I can create a variety of different controllers that will present different user interfaces and react differently to events depending on which one's active. This introduces what we're going to have to deal with as far as multi-threading. So I'm going to go ahead and code this out really quickly. And then I'll take a step back and talk about what's actually going on.
I still demand a nonchalant bull.
Huh?
I still demand a nonchalant bull to go with my volatile one.
Finally, I'm going to have the engine also implement iEvent Publisher. And whenever the engine receives an event that needs to be published to the system, I'm going to have it dispatch it to the current active controller. So whenever the publish method is invoked on our engine, I'm going to say active controller.handle event. When we quit, I'm simply going to say is running as false. When we switch the controller, I'm going to say active controller equals controller. The last bit of code that I'm going to put together is, well, the last 2 bits, is the server connection. I'm going to pass the engine into the server connection, but not as an engine, as an event publisher. Basically, the server connection, like I said, serves as an abstraction over our peer, which means that we need to pass in a reference to an object that will actually be doing the work of handling a server event after the peer has already deserialized the event, which means we're going to have to look down here on onEvent. The onEvent method is invoked whenever the sendEvent method is invoked on a server. It is the opposite of the operation request. So you'll notice on our server, when we say publish, we say sendEvent. Ultimately, that's going to result in Photon shooting the event over the wire and ending up all the way on our client side and invoking the onEvent method that's right here. That's a part of the implementation of iPhoton Peer Listener. So at this point, what we want to do is we want to turn around and send the event that was received from the server back into the event publisher, which in this case is going to be the engine class. And the engine class is going to turn around it and send it into the active controller. So the first thing we need to do is we need to deserialize the event. How do we do that? Very straightforward. Our event equals...
Exact same way we serialized, but backwards.
Alrighty, and then we're going to say event publisher publish event. So that's how we're going to we're going to deserialize the event, shoot it back into the engine, and then the engine's going to send the event to our current active controller, which means we kind of actually need a controller. So I'm going to create a controller called the root controller, which at the moment is going to do absolutely nothing. He's simply going to be the controller that's active when the engine starts, which means he can handle events and he can process inputs. Whenever our root controller is active and we receive an event from the server, this method gets invoked. Whenever the user types the message and hits enter in the console, this method gets invoked. So then in engine, I'm going to go ahead and say, before isRunning equals true, I'm going to say active controller equals new root controller. And I'm going to go ahead and pass in our engine and our server connection. And here's why. The root controller needs to be aware of the engine so that it can switch the active controller when something happens that needs to happen to switch it. Wow, that was bad. So it's going to take in an engine as well as an iCommand dispatcher. And this is how it's going to be able to switch the controller with the engine, or it's going to be able to send a command to the server. Now okay, so let's break down the engine line by line, or let's invoke the engine first. That's fairly straightforward. All we need to do is, instead of instantiating a server connection, I'm going to instantiate an engine. And I'm going to say engine.run, or .start. And for some reason, oh, right. That doesn't matter. Okay, so let's break this down. And probably lost everybody at this point, but I had a lot of code to type out without a whole lot of time to do it. So when we invoke engine.start, what happens is, the first thing we do is we instantiate our server connection abstraction. We pass in the engine itself, but in the form of an event publisher, the IP address we want to connect to, and the application name we want to connect to. Then we instantiate a server thread. Now the server thread is going to be another thread running on our computer that's going to represent this block of executable code. This is a multi-line lambda. And what this server thread is going to do is it's going to continuously check to see, while is running, update the server connection. So make Photon do whatever it needs to do. If Photon received new data, have Photon parse that new data for us and let us know about it. And then sleep for 10 seconds so we don't overburden our CPU. And then once isRunning is set to false and the while loop terminates, we simply say server connection.disconnect. You'll notice something interesting about isRunning. I made isRunning volatile. And that's a little hint that you can give the C# compiler to make it so that if your thread is running on a separate CPU core or a different CPU, the cache that's specific to that core or to that CPU doesn't contain stale versions of this particular field. It's so that Flex. I don't get it. It's so that
I think just because he mentioned threading earlier in relation to that, I was like, yeah, I was right.
So if it wasn't volatile, there would be a potential possibility that we would set isRunning to true, but the other thread wouldn't be notified of that until until a period of time. Okay, so then after we instantiate our server thread, we haven't started our server thread yet, but after we instantiate it, we set isRunning to true, we tell the server connection to start, then we tell the server thread to start, then we tell the active controller to be the new root controller. I'm actually going to reverse this because this is a potential race condition.
And what is a race condition?
Well, a race condition is when two threads compete in such a way that there's a potential for them to be in an invalid state. So, for example, if you have one thread doing one thing and another thread doing another thing, if one thread takes longer than expected to do what it needs to do, it could cause the other thread to be problematic and crash or just produce invalid results.
Basically, whichever one wins the race to get there.
It will change the output.
First
It'll
in.
just change things.
Yeah.
It'll make things not reasonable. The reason I'm doing this is because if I do server connection.connect and server thread.start, there's like a 0.000000001 chance, percent chance that an event will be fired before the root active controller is instantiated, and if an event's fired before the active controller is instantiated, then the publish method will be invoked, and if the publish method is invoked on a null active controller, then an exception will be thrown. So I'm just instantiating the root controller first. And then I say while isRunning, grab the input from the console and tell the active controller to process that input. Once isRunning is set to false, however, go ahead and end the while loop and then say server thread.join. That simply means wait for the server thread to stop and then continue. So pause the thread that we're on until the server thread has been finished.
This I find slightly confusing. I think probably the naming of join or the way you're using it, or just generally something to do with line 42 I find confusing.
Well, realize though...
Is that in the same way as like when you're using a console you use read key, but not to read a key, just to stop things
No, that's
happening?
what this is for, though. This is specifically for blocks
Yeah,
to calling
that's
the thread
what
until a thread terminates.
Oh, so what's it called join then?
Huh?
I don't understand why it's called join.
I don't know. It's just the terminology. Okay, so that's our engine. That's all our engine needs to do. Our engine and our server connection is complete. We now have a basic framework of working with Photon, except for we do not have a single bit of client logic. So let's go ahead and get a login working, and then I'm going to go ahead and pause the video. So a login is going to be very straightforward. Now, but remember an issue that we had. Remember that we can't actually start talking to the server until we get a status code of connect. Until then, we can't dispatch anything because, well, it's not connected. So I'm going to make an event that is only fired on my client side. This event is not fired from the server side. It's fired on the client side, but I'm using the same event infrastructure. Excuse me. Water.
The lengths you'll go to get out of saying infrastructure.
Yeah. Well, take the word that Gavin just said and insert it into the sentence. So we're going to reuse the same event X to handle event curly 0 curly to handle
Sorry, we probably lost all the remaining 10 people.
That's why I'm not worried about this.
Who's still with us, guys?
Yeah, who is still with us? I'm curious because
In all seriousness, because, you know, Dak is, and Brian is, and Mandy is. Hi, Mandy. I didn't know you were here.
I'm worried that people, just like left their computers AFK and just. And I've been basically talking to nobody for like last hour.
I've been trying to stick with it, but I think having seen it once already as well is just, I'm finding it so hard to stay zoned in.
Okay, so I have a fake event here. This event isn't fired from the server, it's fired from the client, but when a certain thing happens. When on status changed event, I'm simply going to say event publisher.publish new server status changed event. And here's why I'm doing that. With this done, this is the last bit of Photon architecture code that we have to deal with. The rest of it can be handled through our controllers. So we start with the root controller. All the root controller is going to do is when it's activated, it's going to say console.writeLine connecting. And then it's going to handle an event. I'm going to say status changed event equals event as status changed event. Or what did I call it? Server status changed event. And then I'm going to say if status changed event does not equal null and status changed event.status code equals status code connect, then I want to switch to the login controller. So I'm going to create a new controller called login controller that implements iController. And what he's going to do is he's going to do that, blah, 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 blah. So when the root controller receives a status changed event, and the status changed event says it's connected, I'm going to say engine, switch controller, new login controller. Then I'm going to pass in the engine and the command dispatcher.
So now, show us what you put into login controller, please.
Hold on, I'm getting an error. Why don't you like me? Why don't you like me?
Parenthetical error, probably.
Oh, derp. There we go. Okay. So here's our login controller. I'm going to go ahead and write this out really quickly because it's going to be very straightforward. Private void, I'm going to make a private void prompt method. It's simply going to say console write player name. Now, when the login controller is activated, I'm going to go ahead and say prompt, and then I'm going to say on process input, I'm going to say if string.is null or white space input, console writeLine invalid username, and then I'm going to say prompt again. Otherwise, I'm going to say commands.dispatch new login command. So here's a first instance of our controller actually sending a command to the server. I'm going to go ahead and add a Boolean flag, private bool is logging in. And I'm going to set that to false at first. And then when we dispatch the login command, I'm going to say is logging in equals true. And then I'm going to say else if not logging is logging in, otherwise prompt. So this way, if they spam their console input, it's only going to send one login command at any particular time. So then what I'm going to go ahead and do is on the handle method. The handle method is going to be invoked whenever an event comes in from the server. And there's two events that the login controller, or three events that the login controller cares about. It cares about the login event, the login failed event, and the room joined event. So I'm going to say var logged in equals event as logged in event. If logged in does not equal null, then I'm going to go ahead and say is logging in. I'm going to keep is logging in as true, And then I'm just going to say console write line, you logged in, just for now. Then I'm going to say var login failed equals event as login failed event. If login failed does not equal null, console write line, login failed is logging in equals false, prompt. Then I'm going to say var room joined equals event as room joined event. If room joined does not equal null, console.writeLine joining room, switching to room controller. Okay. So as far as this client logic goes, how are you guys feeling about it? We have two sort of things. We have processing input, which results at the end of the day in the command being sent to the server. And then we have handling events, which results in the end of the day in us receiving events.
This is one of those things I've found where there's so many kind of steps in the chain that it seems incredibly complicated. This passes to this, gets turned into this, gets passed to this, and finally ends up somewhere. And it's easy to get lost in the journey. But what is actually getting passed around and the route that's, or the sort of the logic of what's happening is actually quite straightforward. Essentially, you know, the server's listening for the client and responding, and vice versa.
Right. Okay, the last thing I'm going to go ahead and do before we go on break here is I'm going to have the server, just for now, this will be fleshed out a little bit better, but when we log in, I'm simply going to publish a new logged in event to the client. Okay, so I'm going to go ahead and build, watch the logs, wait for the application to start. Application has started. Let's go ahead and run. So you'll notice instantly that I get a bunch of bizarre squigglies for some reason for a second, then they go away. You'll notice instantly that it says connecting and then it says player name. What happened here was we started in the root controller. And then the root controller received a server status changed event and switched to the login controller. And the login controller gave us this login prompt. So now I can say player name equals Nelson and hit enter. And now after about a little bit less than a second of lag, I mean, the lag was there, but knowing that we're talking to a server. But then it popped up with you logged in. And we could watch the logs and see some interesting stuff. We see creating peer from 127001, publishing logged in event, command login, command executed. So now I'm going to go ahead and launch this one more time, just so people can watch this happen. Okay. So the last bits of code that we need to put together are going to be the server-side game model, which is going to be incredibly straightforward. And then we need to put together the room controller for the client, which is going to be a little bit of code. So I'm going to go ahead and pause the video, and yeah, we can go on break. We are back. We're back, and we have some code working. We have a little bit of round tripping going on, but we need a little bit more structure on our server to continue. We need our server to do quite a few more things than it's doing right now. We need an actual behavioral model of what's going to happen on the server when different things happen. So the first thing I'm going to go ahead and do is I'm going to create a class called Engine. This is going to represent the server-side game engine logic. Then I'm going to create two more classes. And these are the only classes I'm going to create on the server.
Did I mention ever just how silly a naming system this is?
Yeah, you did.
Well, I find it confusing, and I know what you're doing. you've got two different things called engine.
Okay, so here's my model. I have an engine, a player, and a room. Let's start with the player. What's a player? Well, in our current system, a player has an ID. Actually, it has a player details, which contains an ID as well as a name. Then it also has a current room. Every player has a room that he's in. Then we have a player. And what makes a player a player? Well, a player is always going to be attached to a peer. And I don't want to really pass around peers. I feel that passing around peers is very dirty because it really breaks the sort of separation of concerns that we want to represent with our game logic. This is all...
Well, it's like we were saying earlier about keeping the Photon code away from, well, everything else, really.
Right. So what's a player?
Peer is a Photon-related concept.
Yep. So a player is going to have a player details as well as a reference to an iEvent publisher. The publisher is going to be the abstraction we use to communicate with the peer. Remember, a peer implements iEvent publisher. So by passing around an iEvent publisher, we can, very appropriately deal with abstracting Photon away in a way that really isn't that abstract. It's not very abstract at all. The fact is, there's one method of a peer that we want people to be able to invoke, and that method is publish.
And I find this. It's almost thinking about interfaces the opposite way to how you sort of most normally would. In this case, we're actually using them to restrict what is seen outside more than we're using them to. This is not in terms of sort of composition style usage, really.
Yes.
It's about limiting what is available outside of. Can you put that in?
There's a term for it. It's called role-based interfaces, where you have a single class that implements a variety of what are called roles. So the peer has the iEvent publisher role. So everybody can depend on an iEvent publisher role, and then we can fill in that blank spot with a concrete implementation of a peer, kind of behind the scenes. Okay, so we have a player, and he has a publisher, blah, blah, blah. What can a player do? Well, with our code, this is very simple. A player can have an event published to him, in which case he defers to his publisher, and the player can enter a room, which just sets his current room to a room. And that's all a player can do. Obviously, if you want to follow along and build this out, this is a great starting point for a MUD type application where a player can have more than that. He can have stats, attributes.
Can he not leave a room?
No, he can only enter rooms. That's all a player can do. Okay, so let's go ahead and write our room class. What's our room class? Well, a room is just a collection of players, and it has a name. That's all a room has. So I'm going to say a private read-only dictionary of GUID and player called players. A room also has a name. Every room has a name. A room also can publicly expose all of the players he has in the form of an IEnumerable, which is simply going to be return players.values. Very straightforward stuff. We talked about this in length in C# 102. Okay, so what functionality can a room have? Well, a room can add a player. A room can remove a player. And a room can send a message. Finally, the last thing I'm going to do is I'm going to implement a little helper method on the bottom called private void publish to all. The publish to all method is simply going to wrap a for each loop. For each var player in players player.publish event. That's all it's going to do. It's going to save us some typing, basically. Because very commonly we'll want players to know everything. No, I think Gav's still here. Gavin?
Hmm?
Yeah, he's still here.
I was muted. Oh, sorry, I wasn't looking at BuzzNet. Yeah, no, I'm still here.
Okay, so we have add player, remove player, and send message, and then a private void published to all just as a helper. So when we add a player, what should happen? The first thing that we need to do is we need to tell the player who just joined the room about the room that he just joined. So I'm going to send a room joined event into the player, passing in our name, as well as all of the current players of the room. So I'm going to use a little bit of link to make that process a little smoother. After we tell the player that he's entered a room, we need to tell everybody else that this player entered a room. So we're going to say publish to all new player entered room event player.details. Finally, we're going to add the player to our own internal representation of who's in the room. And then we're going to tell the player himself to enter us. So the player can keep track of what room he's in. Very straightforward stuff. So how do we remove a player? Well, same sort of thing. First thing we do is we say publish to all do player left room event, passing in player.details.id. We tell everybody that the player is leaving, and then we nuke them. So players.remove player details ID. How do we send a message? Very straightforward. We say publish to all new message sent event, passing in player.details.id, the message, and then datetime.utc_now. So here's our room model. Again, very straightforward, but if you could add so many more interesting concepts into this. This is, again, just a starting point.
I mean, there's already more functionality there than there is in BuzzNet. So, well, we don't get a list of players that are in here.
Well, I do.
Yeah, I know, but we don't. But yeah, I mean, you see, this is the thing. There's all of that. I mean, what, 2-3 hours to get through of setting it up and diddly-da around. And it's only really in the last half hour that we've got to anything that's specific to what we want to happen. You know, what am I trying to say? That's specific to this particular...
Right. Once we got to actually running the game logic, it's very straightforward.
Yeah. Wow.
Okay, so the last thing we need to implement is the engine. Sadly, this is going to be, well, it's not going to be that long. Let's just get it over with and have the engine. Basically, so we have our rooms that have the room functionality. We have players that have player functionality, but now we need an engine that kind of puts those two things together. So the first thing I'm going to say, we're going to create something called a sync route on our engine. We're going to use this to synchronize access to our engine class. Because none of the code that I've been writing is thread safe, we can only execute a single command at a time. In order to have made all the code thread safe would have required another 3 to 4 hour discussion about synchronization and locking. So instead, I made the executive decision to simply have every command be single-threaded in regards to an engine. Obviously, this is not appropriate for more real-time games, but it is very much appropriate for things like chat applications or simpler turn-based applications. Okay, so what else do we need? I'm going to have the concept of a lobby. Basically, the engine is going to have a lobby room that's always going to be in existence, that every player joins when they join the game. Then I'm going to say private read-only dictionary string rooms. I'm going to say private read-only hash set string player names. Why am I doing this? Well, I want every player name who joins to be unique. So I'm going to create a hash set of player names to track all of the existing player names in our application and to prevent a new player being created that has the same name of another user.
So a hash set is a form of what that is guaranteeing uniqueness? List or array or
It's its own
what?
thing. A hash set is a collection that can only have one unique value in it per thing.
It's almost like a set of the keys from a dictionary.
Well, yeah, everything has to be unique in a hash set. So let's go ahead and instantiate things. My lobby is going to be a new room with the name of lobby. My rooms is going to be a new dictionary, but I'm going to do something fun here. I'm going to pass in a string compare for this key compare that is current culture ignore case, because I want rooms to be case insensitive. In fact, I also want player names to be case insensitive, and fortunately hash sets allow us to pass in our own quality compares, so we can also pass in string compare dot current culture ignore case. Now our room names and our player names are case insensitive. Finally, I'm going to invoke add room lobby. The add room method is just going to be a little helper method that I'm going to implement in a second here after I stub everything else out. So I'm going to create a public bool try create player that takes the string name, an iEvent publisher, and has an output parameter of a player. Then I'm going to have a public void add player to lobby method. Then I'm going to have a public void join room method. Then I'm going to have a public void exit current room member that will exit a player out of the current room that he's in. And then I'm going to have a nice little method for destroying players. So this is what our engine can do. And then I'm going to have a private void add room method, which is simply going to say rooms add room name room.
Sorry, your join room method, is that adding a player to a room?
Mm-hmm.
Like add player to lobby? Okay, sorry.
But it's slightly different. I chose to break out the concept of a lobby perhaps as a mistake, but I wanted to sort of codify the concept of a lobby into the engine itself. I didn't want there to be some unspoken rule that you have to add a player to a room named lobby. I wanted there to be a method called, well, add player to lobby. I felt that just
cool.
Felt a little nicer. Okay, so let's implement try create player. Very straightforward method. We're going to say if not player names.add name. Now hashset.add will return false if a key in that hash set already exists. So I'm going to say player equals null, return false.
That seems to be something of a standard across the .NET in terms of, well, like try create or int.parse or any of those things where they return a bool and out the relevant info.
Okay, so then if we successfully add a player's name to our hash set without it returning false, we instantiate a player, give it a new GUID, send in the name, and send in the publisher and return true. Straightforward code. It's sort of the gatekeeper into validating player names. Add player to lobby is going to simply say join room player lobby name. That's it. Straightforward stuff. Join room is going to be a little bit more complicated. We're going to say if player.currentRoom does not equal null, then exit current room player. Then we're going to say room. If not rooms try get value room name out room, then we're going to create that room. So we're going to say room equals new room name, and we're going to say add room.
Room.
Yeah, I love saying that.
Sorry, I love it. This is great.
And then finally, at the end of it, once we have a valid room, we're going to say room.addPlayer. Can't really argue with any of this logic. Exit current room is simply going to say exit current room is just about we're going to say var room equals player dot current room. If room equals null, then throw a new invalid operation exception, because they're not in a room right now, so, well, they can't be removed from it. Then we're going to say room.removePlayer, and then we're going to say if room.players.any negated, if I did this backwards. If room.players.any or room equals lobby, return. Otherwise, rooms.remove room.id or room.name.
And this is essentially the corollary to your room.tryGetValue.
Right. If everybody has already left the room, just remove it. Okay, destroy player.
Destroy.
Can't get any more simpler. We just have to say, if not player names dot remove player dot details dot name, throw new invalid operation exception because that player isn't in existence for some reason. And then we're going to say if player dot current room does not equal null, equals null, then return. Otherwise, exit current room player. So.
And again, that's making use of the fact that player names.remove.
Yeah, does both.
Will return.
Not only does it remove it out if it exists, but it will return false if it couldn't find it to remove. Okay, so how do we wire up our engine now? Well, I'm going to go ahead and instantiate the engine in our application. I'm going to say public application engine equals new engine. Straightforward stuff. Field stub, blah, 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 blah. And then I'm going to pass our engine in to our peer instantiation. So every time a peer is instantiated, we're going to pass the engine into it. So our peer is going to take in an engine. And say engine equals engine, create field stub. Next, our peer is going to have to keep track of the player that the peer represents. So I'm going to say private player. So when our login command happens, what we're going to do is we're going to say if not engine try create player command userdib this out player. If that fails, then we're going to go ahead and publish in a login failed event to the user. And then we're simply going to return out. So we're going to tell the user we couldn't log you in because the engine said no, and then we're going to stop executing this code. Otherwise, we're going to say publish new logged in event, and we're going to pass in player.details. And then we're going to say engine add player to lobby player. So yeah. When the join room command happens, we're simply going to say engine.joinRoom. We're going to pass in our player, and then we're going to pass in command.roomName. We're just going to defer to the engine to do that for us. When we send a message, we're going to say if player.currentRoom. Actually, I'm going to leave this as a possible null reference exception. And the reason I'm going to leave this as a possible null reference exception is this will be a null reference exception if the player is not in a current room. Which is fine, because then I would want an exception to be thrown, because obviously we have a bug.
Well, somebody's trying to hack you.
There's two more things we need to do to the engine. The first thing is we need to synchronize access to the engine. So I'm going to say lock engine sync root. Remember, sync root is that little object we created on engine, and I'm just going to prevent multiple people from executing commands simultaneously, to sort of sidestep the whole issue of synchronization.
Just for that one line.
What?
Just for line 76.
Yeah, just for line 76. On disconnect, I'm simply going to say engine.destroy player. In fact, I'm going to do if player does not equal null, then engine.destroy player. The last thing I'm going to do, actually, I lied. I'm going to make a private string getName method. The getName method is going to return player does not equal null, player details name, otherwise remote IP. This is going to help in my logging. So once a player logs in, I want my logs to say sent event to blah, or peer blah is leaving. But obviously, if we haven't logged in yet, our player is going to be null, so then I'll just replace that with the remote IP. So I'm going to change all of our invocations of remote IP into getDame. So I'm going to say command blah executed for blah, command blah failed for blah, And then when we say publishing event to blah, instead of remote IP, we're going to say get name. So now we'll get nice little usernames in our logs, which will make things a lot easier to read for us. So that really completes our server.
Does it work?
No idea, because we don't have a client to test it with.
Good.
But that should be fairly straightforward. We just have to go ahead and create a simple client code. So on my client, our client needs a representation of a room. Our client needs to know what a room is, basically. But our room class on the client is just going to be a mirror of not the functionality of a server room, but the data that the server room has told us is in existence. So our client's representation of a room is simply going to have a private read-only dictionary of GUID and player details called players, public string name, because every room has a name, and then a public IEnumerable of player details called players, which simply returns players.values. Again, we had a long discussion about that in C# 102. Our constructor is simply going to take in a name, and then it's going to instantiate our players dictionary. We're going to have 3 methods. We're going to have an add player, which simply says players.add details ID details. We're going to have a remove player, which simply says players.remove ID. And then we're going to have a public player details get player, GUID ID, which will simply return players at ID. So there's a really basic, straightforward room class that's going to sort of monitor or be monitored by our client, and our client will update this room class, this room object, as things about the room change, such as new players enter or players leave. So the last thing we need to do is the actual code that's going to handle us being in a room. So I'm going to create a room controller. The room controller is going to take in, just like our login controller, it's going to take in an engine and a commands. But it's going to take in a few more things. Because every instantiation of our room controller is going to be specific to a particular room. So we're going to take in addition to engine and commands, we're going to take in a room and a player details that represents the current player. So our room controller knows which room he's representing and which player in the room represents us. So I'm just going to fly through this code really quickly here. The first thing I'm going to handle is the process input method, which is simply going to support the different things that we could do. Actually, I am going to back up really quickly and implement a list players method. And the list players method is simply going to be reused. It's simply going to show a list of players in the room. That's it. Nothing more complicated than that. When we join a room, I simply want to say console writeline entering room blah, room.name, and then list players. Okay, so now let's go ahead and process our input. This is just going to be basic text parsing code, so bear with me for a sec. I'm going to say if string.isNull or whitespace input return. Otherwise, if input at 0 is a /, then go ahead and split it into parts. So input.split space, or more specifically, input substring 1 split space, because we want to pass the /. And then I'm going to say if parts.length equals 2 and parts 0 equals join, then we know the user wants to join a different room. So we're going to say join room parts 1. Otherwise, if parts length equals 1, then we're going to say if parts at 0 is quit, let's simply say engine.quit, else if parts 0 equals list, Then we're going to simply list our players again. Finally, if the input does not start with the slash, we're going to say send message input. So now we have two methods that we want to implement, join room and send message. Both of them are going to be very straightforward. Send message is simply going to say commands.dispatch new send message send message command. And it's going to pass an input as the message. And then join room is going to basically do the same thing. Commands dispatch new join room command room name. So that's all of our actual logic as far as sending commands goes. This is the only bit of information the only bit of text parsing and command dispatching that we're going to need to deal with as far as getting our code to work the way we want it to. The last bit of code is this. We need to handle all of the events that a server can send to us. So what events do we need to handle? We need to handle a join room event or a room joined event first. Why do we need to handle a room joined event? Well, if we join another room, we need to switch to a new controller. So I'm going to go ahead and say if joined room event does not equal null, then var room equals new room, passing in room joined event dot room name. I'm going to say for each var player in room joined event dot current players room add player player. And then I'm going to say engine dot switch controller new room controller. I'm going to pass in the room we just instantiated, our current player, our engine, and our commands. Okay, so that's our first event that we need to handle. We also need to handle a player entered room. So player entered room equals event as player entered room. This will be fired to us as a client if another player enters a room. So all we have to do is say room.add player, player entered room.player details, and then we can say console write line blah join the room. Player entered room, player details name. The opposite of that, we need to handle player left room equals event as player left room. If player left room does not equal null, then we're going to go ahead and say room dot remove player left room dot id, and then we're going to say console write line. Actually, I'm going to get the details out first. I'm going to say details equals room get player left room event player ID, so I can grab the information we know about the player up until this point, so that I can present a nice message to the user. I can say blah left the room, and I can say details dot name. Okay, the last event we need to handle is a message received event or message sent event. So message sent event equals event as message sent event. If message sent event does not equal null, then we can simply say console write line, and I'm going to get the details out of our player. So I'm going to say details equals room dot get player message sent event player ID console write line blah said blah details dot date message sent event dot message. Finally, I do not want this to happen if we were the one who sent that message. So I'm going to say if message sent event dot player ID does not or equals current player.id, simply return because we don't want to deal with that. Okay, so this is the code that's handling the server, letting us know that the state of the server has been updated. The final bit is I need to copy and paste this code into the handle method of this code. Now that we have a room joined event working, we can now have the login controller. When the login controller has a room joined event being published to it, we want to switch to a room controller.
Sorry, what did you nuke?
I didn't nuke. I just copied this. And, well, what I nuked was the old code that just said joining room, switching to room controller.
Cool.
The final bit is that we need to collect a little bit more information on our login controller. Remember, when the logged in event happens, we get our player details, but we don't need our player details until our room joined event happens. So I'm going to go ahead and say private player details. When we successfully log in, I'm going to say details equals logged in.details. And then when we say room joined event, I'm going to pass in details as the current player.
Cool.
So now that I completely and absolutely and utterly lost
Show us a magic trick.
Ooh, we just lost another person too. Huh. Well, too bad for them. I'm about to show
Dropping
a
like
working
flies.
application.
You're actually about to show it. Well, you say that.
Okay, so I'm going to hit Control-Shift-B, wait for my application started to pop up, and then I'm going to run the program and see what happens. Probably going to get a couple of errors, I imagine, but that's typically how stuff like this goes. Okay, so we get an exception on the server side. This is why it's so imperative that you keep logs and you watch them. So we get login command failed for a little bit. System null reference exception. Object reference not set to an instance of an object on model room line 24. So let's go ahead and check out what that code does. Model room line 24. We get player.publish. Players.select. Ooh, I never instantiated my dictionary. See, that's something that ReSharper would tell me.
I was half expecting it to be in the other model room.
Well, it ended up on the server log, so we knew it was from the server. You logged in, entering room lobby. Okay, so we're close, but we have one more error. And this is actually the same mistake I made last week, too.
Hurrah.
Okay.
Do you want to tell people what you just did?
Well,
I'll let them have an error forever.
No, it was an issue where my player left room event is published to the player that left the room, and then I say blah left the room, although my current player has never been added to the room in the internal model because it doesn't really need to be. So when I try to access the player, I got a key reference exception or whatever.
So what did you change?
I just said that if the player that
specifically what did you change?
If the player that left was us, then don't worry about displaying anything to the user. That's all I did. Okay, so let's go ahead and launch a bunch of applications. Okay, so we're running into a small issue. Obviously, these two guys worked properly. I think what actually happened was my application started, and I forgot to wait for my application started event. So let me go ahead and do that again. Blah, 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 blah. Blah, 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 blah. Blah, 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 blah. Okay, so now here is our working application. Just as a quick demonstration of what it is that all that code was. And the funny thing about the code, there wasn't a lot of code. There's about like 500 lines of it, if I'm not mistaken. I wish I calculated the code metrics on it earlier on my other one. Yeah, there's like 300, 400 lines of code in this program. And when I say lines of code, I mean real lines of code, not white space or comments or anything like that. So now you see that as I talk, things show up. But if this guy, for example, joins another room, you'll notice that you see that he left, and then he no longer gets those messages, whereas this guy doesn't send any message to anyone else, but other people can also join the room with them.
Very nice.
And so now you see our log is going a little crazy with a bunch of information, mostly, command send message, command executed for red eye, blah, 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 publishing to all the other people.
Sweet. So there you are. If you followed along, type that all in, you've got a working chat server there now. Mandy Smashes, if not impressed. It's like quite cool. Yeah, that's all right. It'll do.
Well, one of the difficulties I had when preparing this workshop was just the amount of code that you need to, and it isn't that much, really. There's really no.
There's a lot of
classes.
just doing. Yeah, there's a lot of things that need to be done, but none of them it takes a lot of doing. But it's just there's so many of them, they all interconnect.
Well, yeah, and at the end of the day, the only code that really matters at the end of the day are my commands, my events, my 3 controller classes, which represents the entire console user interface, and then my 3 model classes, which represents the entire server domain logic.
Model?
So it's really not that scary. It's just, again, there's a lot of code, a lot of jumping around. There's definitely things that need to be addressed, even as of right now. Synchronization and serialization are 2 things that I've avoided dealing with in this workshop, in particular, because both would add or double, triple, quadruple the length of this workshop individually. But I really wanted to show people not only how you can talk between Photon and a client, but also some of the techniques you can use to make that communication make sense to some extent. So I encourage that people play around with this code, write it out themselves, and kind of see where I came from an architectural perspective and how it came together. One of the coolest things about this system is that this system is not specific to a console application. Now, obviously, all the code I have in Photon test.client is. Now, of course, if we split out the view code into abstract views, then we could reuse these controllers between different environments. But as it stands, the controllers are tied into the view logic. But given this Photon test.base, you can create a client in any language on any platform, because this is all the information you need to communicate between Photon and the client.
Well, if nothing else, you've introduced hash sets to Marvin.
Yeah.
So that's good. No, I think that's cool. I'm starting to sort of get my head around it.
Alrighty.
How many more times are you doing this workshop?
There's no other day scheduled. Alrighty, so how's everybody feeling? Are there any sort of overarching applications?
Wow. Do you want to try that again?
What did I say?
You said, are there any overarching applications?
Are there any overarching questions about the application? See, this is my second 4 hour or 4 hour if you include the breaks class today, so words start not coming out properly.
Yeah. You know how I know that?
Huh.
It's mine too.
Can you show a class diagram for all the projects together? Not all the projects together, I don't know how to do that, but I could show you a... Here's a reference implementation that I have that is similar but not exactly the same. So, for example, the server... blah, 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 blah. Where are you? Here's a class diagram of the server. I mean, really, when I said there wasn't that much code, I mean it. This is the server. I mean, like, seriously, look. If I calculate the code metrics, the server comes out, clocks into 100 lines of code. The client has a few more classes, but if we look at its class diagram, we basically have the engine, then the 3 controllers, and then the model classes. And then, so the engine, the program, the server connection, as well as the iEngine, iController, and iCommand, which I don't really care about. Those aren't relevant. So we have our infrastructure, our kind of framework code right there. We have a custom event called server status changed. We have a model called room. And then we have 3 controllers, login, room, and root. And that's it. And how many lines of code is this? 132. Remember, the way that this calculates lines of codes is real. Wow. The way that this calculates lines of code is a real representation of lines of code and not anything else. Like,
no white space, no curlies, no.
So Photon.base has 53 lines of code, and if we look at its class diagram, oh, no, what?
You brought it into the same class diagram.
Oh, wow, I didn't know I could do that. I'm going to do that on the server, too. Oh, of course it doesn't work on the server. You little piece of stupid. Where are you? Class diagram. Show me the class diagram. Where's the class diagram? There you go. Oh, wow. It does it for the base, but it doesn't do it for the server. I don't know. Okay, so then I'm just going to split it out again. I'm going to go into another.
Is this still the same sentence?
Another thing.
Yeah,
I'm not sure what sentence I'm on right now. So here's the class diagram for the server. We have the events and the commands and the model. That's irrelevant, and these are irrelevant. But what you have here are events, commands, and the model. And that's it. So this is the code. We have the base, which defines the communication protocol between the server and the client. We have the server, which just has the domain logic for the application, as well as the application and the peer classes, which are required by Photon. And then we have the client, which just has 3 controllers, 1 model class, 1 custom event, and 3 architecture classes, 3 infrastructure classes.
And I mean, from here you can go, once you've logged in, rather than going to a room controller, you could go to a
Character selection.
Main menu of a game controller, a main menu controller, or a character selection controller, or a new character controller.
Yep.
And it simply involves very little in the way of actually additional, adding code to the stuff that's already there.
Right, and if you were to represent the exact same logic without this sort of architecture, you'd end up with almost the exact same amount of code, it just wouldn't have organization to it. There's very little amounts of boilerplate you have to do. The only boilerplate I can think of that you have to do is the constructors get really big, but that's about it. But yeah, so how's everyone feeling? Because we haven't lost anyone in the last 30 minutes. There's that. But we're at 3 hours of recorded time and 4.5 hours of time. So I think it's almost about time that we just wrap up.
Yay! I mean, who?
So are there any questions, any thoughts about this? Any comments or critiques about the way that this was approached is definitely welcome. PM me, email me, PM Gav. Post on the forums.
No, don't PM me.
Well,
shut up. Why are you telling people to PM me? Don't PM me. I don't want to talk to people. Yeah, PM Nelson. You say you tell them to PM you, you never read your private message anyway.
I do. Yeah, as far as the prerequisites, I was really thinking about people who had just finished 102. There are some things that weren't even talked about in 102, such as my use of link, which I did a few times. Maybe I think in the engine I used like link once. Yeah, room.players.any.
You used a dot any.
But I
Yeah.
think I also used .select somewhere. But other than that, that was one of the things that one of the caveats that I specified was, I wanted to target a 102 level, but with a few cool tricks that make code easier to write, such as, let me actually pull up the code.
I think it is a case of, no, I don't think anyone, there's even probably someone who was close to your level of coding speed but unfamiliar with the territory could keep up and actually code along with you. I think you have to go back through it and pause and study it and actually code it up in slow motion, really. And certainly towards the end you were rattling through at a hell of a speed, but
Yeah.
by that point you were into
Well, it was out of necessity.
logic.
I was typing almost this entire time, and we're still at 3 hours of recorded time.
Yeah. No, you did a good job. But
what other workshops?
But yeah,
well, actually, I'm going to go ahead and end the recording. Doesn't seem like anybody has any questions about the code stuff. Well, as far as what other workshops I want to do, I'll answer that in a second.
Goodbye, future people.
Yes, goodbye, future people.